Hello. Okay, great. Hello, everyone. Good afternoon. I'm Vanshika. I work at Gnosis, and I'm going to be the moderator for this particular afternoon. I've got amazing lineup of speakers for you folks. I hope you had a great lunch. The first person coming up in the series is Jerome from Ethereum, France. He will be talking about the state problem, one account and multiple chains. So let's give him a round of applause.
Whoa! Hello, everyone. Super happy to be here. Last time I was here, it was to talk about a castle in the town of Eve. And now we're talking about the state problem. So where have we been? Where have we been? So I'm the founder and CEO of Cometh. You maybe heard of us. I'm also teaching here and there, and I'm indeed the president of Ethereum France. I hope to see you all at ECC in July. It's going to be a bash. Yeah, hopefully see you at ECC. So before we start to deep dive, I want to give you the angle that we have when we talk about this problem. At Cometh, we are a gaming company. We do games. We've been doing on-chain games. We've been doing less on-chain games, and recently we started a game on Epic Game Store, distributed there. And we do also the tech stack for those games to work. So we distribute middlewares for retail application, and notably we work with Gnosis on Metri. So while we were trying to onboard people into games, when we were trying to onboard non-Web3 minded people into retail blockchain application, we were faced with a huge customer acquisition problem. Because you need to install a wallet, because you need backup, because you need to buy crypto, because you need crypto to use on the chain, and so on. And for us, it was just a nightmare. The conversion funnel was just so bad. It was in the year 2021 and 2022, so we didn't have as many fancy techniques as we do right now to onboard. And for our latest game, we moved to full account abstraction that we distribute and package on top of Safe, and also on our own layer 3 on top of Arbitrum, so we have the capacity to properly sponsor transaction for the user. Now, here's what we think is going to be the low-hanging fruit in terms of user acquisition. Here's Bob. So Bob has ETH on a centralized exchange. So he's already crypto interested, crypto minded. It's easier to convert those people than it is to convert someone that has heard about Bitcoin but think it's for terrorism and money laundering. And it's also easier to convert those people than just say like, hey, it's cool, it's on the blockchain, you should check it out. So typically, when you have a full account abstraction application, the user don't really see their account at first. They just get onboarded as they would on any Web2 application. And when they start to dig in, they realize that they have a wallet, and they may be willing to withdraw some money on this account and start to use this account elsewhere or in another way. So we have many Bobs already in our games, like people that have onboarded on our game, that have tried to do transactions that were sponsored, didn't really realize what was happening, started to put their own wallet to grow the number of owners of the safe, for example. And at some point, many of them decide to withdraw from their centralized exchange to their safe that we deployed for them. And thus they rush on the Discord asking like, oh, where's my money? I don't know. Where's my balance was out of date, and so on. And then we get into, from what we perceive is a pretty big state problem. Like the state of the different EVMs that we have deployed are not properly shared together. And as of today, we are entering a change of paradigm. I mean, you've seen this in this conference. Umbire, Metri, Monerium, Clave, Gnosis Pay, and so on. We start to have a lot of very good way to onboard people. So we are likely going to get a lot of Bobs, and this problem is going to get bigger and bigger. Thankfully, the best minds in our ecosystem are thinking hard on this problem, and so like Vitalik and other people are posting a lot of research stuff about this problem, like making sure that we have eventually a minimum key store rollup where we store everything that's happening in the account, and we replicate the state of the account this way between different chains, trying to suggest things that we should do in order to improve the situation, because the problem is about to grow a lot. Coming back from when we started Ethereum, when we were using Ethereum and installing a node, the first thing you were supposed to do is go on the Ethereum browser called Mist. Once you were running an Ethereum node, you had Mist installed on your machine. And Mist was connected to your node, and you were browsing the Web 3.0 through Mist. And every time you had a request for something blockchain related, then Mist will just talk to your node, and you will access the blockchain data this way. Unfortunately, it was a bit too hard to push people to all install a node in order to access the blockchain. We started to have wallets like MetaMask, like others, that were exposing remote procedure call, RPC, towards nodes like Infura and so on. And then we started to lose a bit this strong connection to the chain, like putting everything that's available on chain directly on the computer of the user. Well, then we started to switch about how we are going to scale the network. And the first attempt of scaling Ethereum was to use the beacon chain as a coordination layer, as a coordination layer between different shards where things were going to be executed and everything would be reconciled towards the beacon chain. So beacon chain as a coordination layer asked the tough problem of how do we make sure that there is cross-shard communication. And in the years 2018, 2019, early 2020 a little bit, everybody was thinking about that. Like, how do we do good cross-chain communication problem? The main problem was shaped as the hotel train problem. Like, if there is a hotel on this shard and a train on that shard, how do I make sure I do one single reservation, one single booking to access my train and tickets? So all the techniques that we started to shape at this stage were asynchronous or synchronous, and they translated themselves into different attempts at doing good bridges between chains. The number of bridges hack, the cost of using bridges, and the maturity of those bridges highlights how much we need to work a little bit more on those problems. And today we have this roll-up scaling strategy, which has been very successful into giving us a lot of EVM block space to fill. So we switched to having Ethereum as a beacon chain connecting all the shards and making sure that the communication is good between those shards into several layers of layer one, several stages of layer one. So you have the execution layer, like where we actually run the transaction, the mainnet, the EVM on the mainnet. And we have the consensus layer, a way to get the consensus on proof of stake of what is the stage of the layer one, but also to gather some data, like the blobs from the EIP 4844. The data can be a bit misleading because this data is not supposed to be permanent. It's supposed to be there for a while just to guarantee some security aspect. And then all the rollups, all the L2s and L3s and so on, can communicate with the layer one and benefit from the blobs and the consensus layer and the execution layer to continue acting and providing security to the user. But it feels like we kind of forget that we need good cross-layer communication. So a big lingering question for me is, are we going to get enough block space to dilute this problem into more gas spending? And as of today, we have a few researchers, notably Ankit and Stefan from Frontier Research, that are trying to shape this problem in the rollup context, in the multiple EVM context, without any good coordination layer. So they came out with the CAKE framework for chain abstraction key elements that highlights the different components that you do need to realize a good cross-chain abstraction, a good chain abstraction, to have good abstraction of the chain you are in for a user. When as a user you browse a website, you're not asking yourself, is this website on AWS? Are they using GCP? I'm not sure. I need money on GCP to use it. Yes, indeed. And the end game would be, of course, that my wallet, j.ishe.eth, is showing me the balance that I have on all the networks together all at once. Like eventually with a weighted fashion, say like, oh yeah, but you need to pay X to get out of this and get there, but this is what you have in your wallet in the first place. So in order to get there, I tried to look at those different components. Of course, you don't need all the components to realize a good solution. There's mixes that can be done. But looking at the different companies that were building on those different components and trying to say, like, well, they only have a landing page, no code is public, the documentation is out there, oh yeah, they're live on this network, on that network. I tried to gauge how much we were mature on the topic. So that's my personal view on this. Maybe I missed a lot of people that were trying to build in this space, but we still have a lot of work to do to make it workable from my perspective. And also, if you want to do chain abstraction as a whole, you need to be supporting a lot of chains. So it means that your infrastructure needs to be super scalable as well. So yeah, adding problems on top of the problems. Couple of highlights though. At this conference, there were a talk about ASHI, which is the cross-chain alliance that's going to look at this problem and try to bring solution or bring together different initiatives towards this solution. And also the work that we did in R&D at ComF called Storyless, which is storage proofs, like proving that something is included in an EVM, and trying to figure out how we index that and distribute that at a large space. We will do some updates on that at ECC, very likely, and if you want to check it out, the code is also there. And as a conclusion, we still have 10 minutes, that's great. I wanted to give an opportunity for Stefan to get a deeper dive on One Balance, which is an initiative that builds on top of the Cake framework to realize what we think is going to be the next big thing in terms of account abstraction and chain abstraction. So please, Stefan.
Amazing. Thank you so much, Jerome, and so kind of you to give up some of your time. I know you have to run to the airport soon, and so I really appreciate it. Big shout out to him. I mean, what a legend in the space, and so yeah, feeling blessed for the opportunity. Okay, let's talk a little bit about One Balance. You know, leveraging a bit of what he's talking about with the Cake framework. First, we can talk about why we care about chain abstraction at all. And so I think everyone realizes that the best time they've had on Ethereum so far was a few years ago, when it was easy to farm vegetable coins and it was like one-click experiences, but it also was really expensive to do so. And so we spent the better part of the last 4 years trying to figure out how do we actually make it so it doesn't cost $1 million just to do a transaction. And we've managed to achieve it, but now we're in this world where we have fragmentation across the entire ecosystem, and I've found it extremely difficult to use the chain, and I'm sure I'm not the only one. And so unless you're really motivated, and in many cases financially motivated to do so, it makes very little sense for users to go figure out this mess. And so how do we actually get to the dream world that we want to be in, where we actually have both the usability and the scalability? That's sort of the problem that chain abstraction is trying to solve for. And so we proposed this framework called the Cake framework. And the entire thesis behind this is, if we solve the Cake framework, we get to the world that we want to be in. The other part of it is, we believe each one of these components, we stand on the shoulders of giants, and there's a ton of money that's been spent trying to solve these issues. The main issue is that these people aren't really talking to each other, and they're integrating sort of common interface to be able to achieve the UX improvement. And so that's what the fragmentation comes from. It's not just about like technical fragmentation, it's like social language of the developer community not talking to each other fragmentation. So that's what we're looking to solve with this working group. So we just have a bunch of different folks here, and these are all sort of middleware sort of layer folks. And then we're launching a new work stream for wallets and apps. And so anyone that's working more towards the UX of solving these problems, we have a new group for this. So that's my Cake plug. And then I would love to talk a little bit about One Balance and what I call the fat account thesis. So I think we've been in this sort of view of the world since 2016, more or less, that focuses on the idea that the chains and the L1s is where the majority of the value accrues. And if you look at sort of the top 100 coins on CoinGecko, the majority of them are sort of L1 protocols, right? But there isn't really anything that sort of backs this meme. And as far as I can tell, this is sort of the source of it. So the idea for fat protocols is saying, oh, actually all the network effects accrue to the base layer where the smart contracts are actually operating. My claim is that this is actually an outdated view of the world. And this is based off of a perceived scarcity of block space, which we no longer have. And in a post-abundance of block space world, what we actually go towards is what I call the fat account thesis. So the chain-centric view says, okay, we have credible commitment machines and global consensus that are bundled together. And because you're bundling global consensus, it's really slow and expensive to do, and so therefore it's going to accumulate a lot of value and it's going to have network effects. What I'm proposing is, now that we're in a post-block space scarcity world, actually what we're bundling together is the account and the credible commitment machine, and we're taking out the global consensus. And this completely shifts the ecosystem from focusing on chains to focusing on accounts. And my claim is this transition is both inevitable and necessary if we want to solve all of the UX problems that the fragmented space has today. So, what is our contribution to this? Our contribution is looking at the equivocation and global consensus dilemma. So equivocation comes from sort of the way that EOA accounts are designed today. So EOA accounts are public-private key pairs, and they sit outside of the chain. And so the chain has no view over what the account has or hasn't signed. As far as the chain knows, any request that is a valid signature over a given nonce needs to be processed in compliance with the consensus of the protocol. And so at any time, a user is able to equivocate their request by simply overriding their nonce. And so this nonce overriding is possible because the chain doesn't have this view. The problem is, if you're relying on an architecture, like in the cake framework, where a counterparty brings the transaction to the chain on behalf of a user, if the user is able to equivocate, they can essentially grief the solver. And this issue becomes even bigger in a cross-chain setting where you have asynchrony. Because if the user issues a request over here on chain A, and then the solver does something over here on chain B, they can't rely on the atomicity of execution between these two things to provide safety over their request. And so they can't revert if the user double spends on chain A. The class of solution for this is sort of widely known as HTLCs. It sort of says, okay, well, we actually need to lock the user state on the origin chain for a period of time to allow time for asynchronous execution to happen on the other network. So this is where we go into sort of the next evolution after EOAs, which is the concept of smart contract accounts. And so one solution to this equivocation problem is to say, let's just put the account on chain. Now the chain has a view over everything that the account signs, and so the chain is able to say, oh, this account has locked this state for this period of time. It's credible because that state is locked on chain, and it's within the rules of the global consensus. The problem with this is global consensus is really expensive. And so we enter into this thing called the account dilemma, where on one side you have EOAs, which are fast and cheap, and you can issue a bunch of different signatures basically at the speed of signing, but you allow the user to equivocate at any time. And then on the other side, you have smart contract accounts, which can't equivocate because they're part of a credible commitment machine, but they're really slow and expensive because of global consensus. And so the dream world that we need to be able to achieve chain abstraction is top right corner, 2-2. And I'm going to present sort of what I think we need to get there. So that's what one balance is trying to resolve, is this dilemma. The way that we do so is by introducing the concept of a credible account. So credible account is sort of a successor to smart contract account. And it says, actually, instead of hosting accounts directly on a chain with global consensus, accounts can be hosted on any credible commitment machine that's mutually agreeable between the user and the solver. That's a key point. We'll get more into that. And then the other piece I introduce is the idea of a resource lock. So a resource lock is like a really scaled down version of call data that actually doesn't specify anything about the execution trace or the execution semantic on the destination chain. It only specifies the inputs and the outputs of a specific state transition. And it lets the solver figure out the rest. So these locks are these like credible commitments. So they're escrows that are issued within the account that solvers can rely on for the period of time that this escrow is in practice. So this is an HTLC at the account level. And then credible accounts. So credible accounts are, again, just accounts that are hosted on a credible commitment machine, which allow for the fast and cheap fulfillment. One way to think about this is take smart contract wallets and put them such that each smart contract wallet is its own roll-up that's able to deposit state from an arbitrary number of chains. And it's able to process transactions really, really quickly because it has its own sequencer, and it doesn't have any dependencies on anything outside, but it's able to trigger state transition functions on any other domain. That's essentially the world that I'm proposing we head towards. There's many different ways to get there. So we explored in our post 4 different architectures that we believe sort of achieve this outcome. I call them like the 4 architectures for credible accounts. One of them is using trusted execution environments like SGX. Another one is by using an MPC and doing threshold signatures over sort of a consensus of nodes. Another one is putting this sort of smart contract accounts on a roll-up approach. And finally, some of the more recent discussion is around the use of VM modifications directly, like 7702. So all of these try to achieve sort of the same thing, and they all come with different trade-offs. I expect that the optimal implementation of this is going to evolve over the course of the next few years as as we make the transition towards this account-centric worldview. I posit that this new worldview is necessary and inevitable. And what we're building is a framework for being able to manage these types of accounts on a bunch of different architectures. And so we consider every part of the cake stack sort of a module or a plugin that fits into these new types of credible accounts. So yeah, there's a link here if you want to learn more about it. And again, thank you so much, Jerome, for the stage space. Appreciate it.
You want to take questions?
Oh yeah? Okay.
All right. Does anyone have any questions? Yes.
Hi, thanks for this presentation. But I'm wondering how to create a smooth transition to new proposed accounts, because currently we have a huge problem with legacy. For example, we have a ERC20 standard, then maker token doesn't support name or symbol in string value, it returns byte 32. And all time when new innovations come, we create like a EVM versioning when one EVM version does not support PASH0 opcode or T-store opcode and so on. And when the new accounts could come, how the current code base, for example, Uniswap or Aave or any other big protocols could support these new accounts to make it seamless transaction to users without not rebuilding the whole code base of really well battle-tested protocols.
Yeah, I have an answer, but I mean, you've seen this firsthand with the transition to smart contract.
Yeah,
accounts, right?
there's many discussion happening right now on how we make people transition from EOA to smart accounts. It's completely opt-in. You don't know, you're not technically supposed to be forced to be transitioning to any smart accounts. But there is a lot of very good arguments that this should be the case, and this should be at some point the default as well, notably with rolling out different keys and being able to change your keys and so on. There was an initiative that got replaced recently by another one, the EIP 3074, that was supposed to be included in the next fork, that will be replaced with another EIP that's more aiming towards a smart account as a transition. So at the EVM core level, we are introducing ways for people to migrate easily from their EOAs to smart accounts. And what we'll be doing is like, oh, I'm taking my MetaMask and I'm now declaring that this MetaMask is now invoked by this new smart account. The good thing for existing smart accounts, smart contracts like Uniswap and blah, 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 is that from a smart contract perspective, talking to a smart account that has been transitioned from a EOA will be the same. The transaction origin will be the same. You'll be invoking from this account. And so there's no change to be done while we do this transition. And this transition is already happening and already like in target.
Yeah, so I think it touches really well on the smart contract account sort of transition. My claim is maybe a little bit more meta, which is I see current EOAs as an inadequate equilibrium, if you're familiar with that concept. And like a lot of standards are poorly designed are. They're kind of these things that everyone uses because everyone else uses, but they would rather be using something else. And there's like clearly something else that's better. And so I see my job in the Ethereum ecosystem or the crypto ecosystem as a whole to like help the community switch from one inadequate equilibria to like a better one. And that's a coordination problem. Like any standard is a coordination problem, any blockchain technology is a coordination problem. And so when you ask this question, what I hear is, how do we solve the coordination problem, getting people to switch over from an inadequate equilibrium to a proper one? It takes a lot of like presenting things, getting people excited about it, and all this stuff. But fundamentally, people only shift when they have an incentive to do so. And so I believe that this is inevitable because the capabilities that it delivers for end users is so much better that the applications that integrate this first are going to have a huge advantage over current applications. Like this is over a 10x improvement over the current state of things with EOAs. And so it's inevitable that people will innovate and start to adopt this, and then eventually the bigger folks that are slower to move are also going to change. Practically, what needs to happen is we need to switch away from this JSON RPC API that was designed in like 2014 to manage EOAs on Ethereum nodes towards an RPC API that's actually designed for wallets. And there's a bunch of different proposals, and so we're working with folks like Wallet Connect to get these new methods that are much more modern deployed within all of these different wallets and apps.
Yeah, smart accounts at scale are cheaper for the network.
Yes. Yes. Anything else?
I think we're out of time.
Okay.
Anyway,
thank you for the question.
Let's chat if you want to deep dive more. Cheers.
All right. Thanks, Jerome, for an amazing presentation. Next up, we have Elon Aviv from Collider, who is going to talk about how is Web3 going to un-FD AirTech.
Yeah, can you hear me? Cool. So what's up, guys? I hope lunch was good. I mean, to be honest, it wasn't that good yesterday, but I didn't eat here. So I will preface this, but I think something that is important, and I think it's something that has come up here a lot. I think we have to transition to a phase where we start building consumer applications. For the past 7 or 8 years, we've been building infra, building meta, infra, building abstractions, and we have to move towards building consumer applications because otherwise we're going to continue just like circle jerking these things. And unfortunately, I think it's like Americans who historically have done consumer applications well, and we have a problem, basically. And I would like to see like more European companies and more folks sort of trying to tackle this. And ad tech, unfortunately or fortunately, has a lot to do with this. So, yeah, okay. We'll start with, wait, one sec, about ads. Who likes ads in Web3? Yeah, no one? Like just, this is like scrolling a bit on Twitter or like just Googling crypto ads, and it's all scams. I mean, it's true. Like it's all scams, it's all grifting stuff, and actually most times, like the ad tech industry, even if it wasn't scams, is like so counterpositioned to the values that we have in Web3 of like ownership and sovereignty and transparency and all that stuff. It's like completely the reverse. So just to start with that, and I will just quickly talk about, like, introduce myself. So I worked for a company called Iron Source, which is an Israeli ad tech company, and they sent me to China to sort of like help train the office there, and I was there for 3 years. While there, I read about the DAO hack, accidentally created the largest crypto community in China, learned about Bitcoin, learned about DAOs, and then started, I had a startup, started advising crypto startups. After I closed that, I was a part of the XDAO, where I see some folks here from the XDAO, and now I'm with Collider, which is a venture fund out of Israel. So, yeah. That's about me. So what do you guys know about advertisements? Anyone knows who's the guy on the left here, on the bottom left? Yeah? No one? So this is Edward Bernays. He is sort of like the father of public relations, the father of propaganda. He's the nephew of Freud. And he famously, if you see the women right next to him, there was a campaign called the Torches of Freedom, which essentially the cigarette companies saw that women are not smoking, and that's like literally 50% of the market. So he rode the sort of feminist movement and told them to like light cigarettes and like a big feminist movement sort of occasion. And obviously, the sales of cigarettes rose. On the bottom right here, it's the first ad that has ever existed on the internet in 1994. A banner. as you can see. And at the top here, that's David Ben-Gurion. I mean, it's super controversial right now, I guess, but it's from the famous Apple ad about the odd ones, I guess, the square pegs in a round hole. So I want to talk quickly about the rise of mobile and what happened, because that's something that I know very well. So I guess like the iPhone in the early 2010s started. There was like competition between Apple and Samsung, and then advancements in chips allowed this to be sort of like mass-produced. Another thing that sort of happened is like the evolution of JavaScript, right? Like Node.js Cloud has essentially made applications and development of applications so much simpler. And social media with Facebook, which was first on the computers and on the web, and then later as a phone, on the phone became essentially the killer app. And that's kind of like how mobile evolved. But one thing that people overlook a lot is the rise of mobile ad tech and the ability to sort of discover applications. So there's a few things, right? There's analytics, like I am able to buy a user for $1, and I know that that user is worth $1.20 for me, so I will always pay $1 to get that user. And so there's like all these parameters like lifetime value, cost per acquisition, return of ad spend, and sort of like the analytics industry sort of very much evolved. Another thing that evolved is the business model. On the top right here, you'll see, wow, it cut, but it's, or is it very small? So like this is the share of applications that are paid, right? Less than 10% in both Android and iOS are paid applications. What does that mean? How does the developer make money? And I saw it firsthand, especially with games, that you develop a game, but no one's really paying. No one's buying in-app purchases stuff. So the result is that these guys had no way to monetize. And using ads, and this really came up in like 2014 with things like, I guess like freemium and stuff like that, new sort of like ad formats emerged. And these ad formats were like, the thing in the middle here, you can either buy 5 more lives, or you can watch a video, an ad, and then get another life, on Candy Crush or something of that sort. So, like, it sort of changed, the ad tech changed how these things worked. And so this is not sort of like without problems, right? And you have Zuckerberg here, that says, the more of your data I gather, the more I understand what it means to be human, right? Facebook and Google controlled essentially all of the ad market, and then most recently, Apple killed IDFA, and Google is probably going to have to follow suit, which was like the ability to target people across the web. So right now, Apple is going to ask you for permission to actually track you. And the ad tech market is growing, blah, blah, blah. Like, you're obviously understanding this. Everybody knows. So my take is that Web3 is going to dramatically affect how the ad tech market is going to look like and how it's going to grow. So kind of like history rhymes, just like the rise of mobile. I think we are at the point where we have UX abstraction with like smart accounts and stuff like that, what was actually previously talked here, and even with like PWAs. I like this quote from Kane, crazy how many problems we have solved or about to be solved for deploying crypto projects, because in his time, when he deployed Synthetics, he had to build everything from scratch, all the infra. So now you have like the graph, you have Alchemy, you have all these EVA modules, you have all these wallet abstractions. And finally, the stack to discover applications, to figure out what is out there is emerging. There's like audience definition and analytics, there's attribution, there's ad matchmaking and delivery, and there's discovery. And the last thing I want to say is that, when I first started and I came here and I said like ads, like the initial reaction from everyone is like, no, not ads. It's what I call like a severe allergic reaction. And the reality, I think we have to rebrand it in crypto, and we'll talk about this in a bit, but what about the word incentives? I think it's like very apt. So how is Web3 going to change ad tech? I think one of the things that happen that we can do in crypto is we have alignment, right? We can set some standards, and we can set shared ownership. Imagine there's like an ad network, and everybody who's seeing ads is a part of that ad network. They have tokens in it, or whatever sort of coordination you want. And this essentially creates trust. So right now, the things that we have to do that is like like airdrop and liquidity mining, and that's just a form of advertising that is very, very bad because we didn't want to do like advertising. Another thing that this will sort of like enable is recurring engagement. You can directly connect with the wallet or the person who you are sort of targeting. And yeah, like I mentioned, kind of like opt-in frameworks. If I give in more of my data, if I can share more of what I'm doing online, maybe I will get a bigger share of the rewards that I'm supposed to get, and distribution and ownership in the network. Another thing that is a bit overlooked is, who remembers the ribbon finance sort of like thing where their airdrop was farmed by one of their VCs? Who remembers this? Show of hands. No one? Yeah? So yeah, they came up, they like one of the VCs basically created like hundreds of accounts and essentially farmed their airdrop. And one of the biggest problems in ad tech is fraud. Like, if you get paid to download an app, then people are going to massively sort of like inflate that and try to sort of make a shitload of money. And so what happened here is, because it's transparent, because you can look at the blockchain and see sort of like what happened, they were caught. And they weren't just caught, their intern was using their ENS name, and it was very easy to sort of like follow them, and it was just like a whole debacle. So like I said before, instead of calling it ads, we should call it incentives. And want to touch a bit on like, how is this going to look like? So I think we can have dynamic incentives, what I would call. So imagine if you have some on-chain behavior. If you're a whale, you'll be incentivized to maybe provide liquidity. If you're not a whale, maybe you'll be incentivized to just trade on the platform. Or this could be your progress in a game, what you can do in other places. And the fact that you have such a rich place with data, which is your wallet, and you can read and you can figure out, according to the things in the wallet, what might be interesting for you. I think that opens up to like a lot of different things. Another thing is like you can create like interactive things that are catered specifically to you. You can do like social graph-based rewards, right? If I am sharing something, I mean, it's kind of already happening like with referral programs. But if you can like bake this into like, I don't know, my Farcaster social graph, and the more people come through my Farcaster ID, then things could look like a lot more interesting. And yeah, like, obviously like limited reward stuff, all of these things are already happening, but standardizing this could be like super interesting. Like, okay, the first 100 people that share their ETH address can get this NFT, or stuff like that. So I'll give a few examples. I don't know if you guys know, I put you guys in there. So on the left here, there's on Farcaster, someone put essentially an ad, and the space is for sale. It's completely static. It doesn't really read your wallet. And on Farcaster, what you can do, as soon as you interact with the frame, you can see the wallet address. And then if you have the wallet address, you can see what they've done. And then you could customize what is the ad that they're seeing according to the wallet. We have the folks here from Outpost that if you're not already on it, it's essentially, let me know if I butcher it, but a wallet-based newsletter. So it reads what you have in your wallet, and according to what you've interacted with, or according to the communities you're a part of, it will show you a feed of what they think is interesting for you from across sort of the web. And then you have Coinbase, which they have a spotlight, which, according to what you are, according to what you've done in the Coinbase wallet, you'll be offered to, mint a Shield Basics NFT because you've done some like basic things. Yeah, I think in general, like this shift is sort of taking the Web3 values of ownership and transparency and that type of things and baking them into some of the most dystopian industries that we've ever had. Like what created the most amount of spying on people and generating data that people don't even know that they've been collected on, right? Like everybody knows this thing where they would say giraffe with their phone, with their friends on the phone, next to the phone, giraffe, 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 and then they'll see like ads to go to the safari or something. And like these things have happened. So like these, like what we can do with Web3 values can actually change how shitty and I guess disgusting Attic has been. Another thing, it's kind of like we are changing how sort of like value is distributed. One sec, yeah. And how we sort of like value attention. Like if right now in Google and Facebook, I don't get anything, right? I see an ad, maybe the Facebook gets some money from the advertiser, but I don't get anything from that. And now you'll be able to sort of like be a part of this puzzle. And yeah, I think like Web3 right now, it's sort of like a teenager in adolescence, which doesn't really know anything about himself and the world. And now we're finally getting to some like data-driven stuff. We're beginning to quantify like our users and how to get them and how to grow them. And this has to happen. This has to happen if we want the industry in and of itself to scale. And yeah, just like mobile game developers couldn't monetize if there weren't any ads, so will many websites and so many avenues in crypto will be able to monetize through showing like targeted incentives inside their platforms. So yeah, that's it. Any thoughts? Yeah? Yeah.
Do you think it's possible to create like one profile for a user, for a Web3 user? Because what you said is that you have the data from your wallet, but I have like 3 different wallets. I have my L2 wallet, I have a Coinbase, MetaMask. So how is it possible to create like one profile, like a user profile to...
So I think that this is a problem. I have like 20, honestly. Like 20 wallets that I use for like different things because I also like value privacy. And like this is a very interesting question on how this is going to work. I'll comment this from the other side. Do you even want to be targeted by a wallet? I mean, that's kind of like, it has your financial history. It's kind of like this entire complex thing of, like, maybe I don't want people to see everything that I've done on chain. And then how do you interact with something like this? And I mean, Sysmo tried to do things like that. Like back in the day with like ZK proofs, I'll be able to prove that I have an ape on some wallet because I signed a transaction without proving like which is the wallet, for example. They're not doing that anymore. And I think maybe it was kind of like an overkill to do that. But at the end of the day, like, these guys, you can ask them from Outpost. This is kind of the question that I asked them yesterday, because I connected with one of my main wallets that has like most of my interactions, but I have another wallet that's not in that. So can I add that wallet to that list, or maybe can I add like multiple wallets? That's something to be seen. And then maybe you want to create an abstraction for that. Maybe you want to, okay, I'm going to mint an NFT that represents my wallet history, and then I can update that NFT according to sort of like what is continuing to happen or what else I'm interested in. I don't know how this is going to turn out. So yeah. Does that answer the question? Yeah?
Hi. I guess another question is also related to CPMs that are being paid currently by advertisers. For example, we run a site with, I don't know, thousands of visitors. And anyways, our impression was that, for example, the CPM that we get from these, I guess, like advertising dealers or whatever, is actually very low. So if I would spend with my co-founder some time building a feature that allows me to mint an NFT or whatever, like something that my users like. I might make more easily money doing that instead of selling ads on my website, because at the end of the day, connecting a wallet is actually so much less friction once you have connected it compared to, let's say, putting a credit card into a website, right?
Yeah.
And stuff like that. So I also wonder, what is your, how do you think that will develop, considering that it's so easy to spend money on Web3 that I almost feel like maybe that just, I don't know, it just really shifts the dynamics.
Yeah. So yeah. So to start with, I actually think like CPM is like cost per mil, so cost per usually 1,000 impressions. I think that's sort of outdated, and we're going to shift, like it's already been shifted to like, you know, there's cost per click, CPC, and then there's cost per install, like in an apps, and then there's even deeper, which is like cost per action. So this means that if I am an advertiser, I'm going to pay for a certain action that user does. And let's say, you know, that the easiest example is, I don't know, I'm about to trade on Uniswap, for example, through my Coinbase wallet. And Coinbase knows that I'm about to do a transaction that maybe CowSwap wants to offer me to do the same transaction through CowSwap, but you know, they know that they can give me a better price because CowSwap has solvers and, you know, that type of stuff. So I think it will trend towards that, and then kind of it will still be in the flow of the on-chain stuff, right? It will still be like, I am like trading, I want to switch from USDC to Ether or whatever, and I'll be able to be quote unquote intercepted in a very good time to go somewhere else. And you know, CowSwap is willing to pay maybe $1 or $2 to both, you know, the wallet and then maybe the user as well. Hey, you're going to get a rebate in gas or something like that. So I think it will trend to these type of things. Actually, I forgot. I wanted to say an example. That when I was in China, there was, I don't know if people remember, like there used to be Android devices where you would click to clean the cache of the Android device, right? And so I was working with like the biggest Chinese company to do that. And after we iterated on a bunch of stuff, and like how to show the ad, when to show the ad. And you know, this is what we learned in retrospect, but what we landed on was like, you go and clean, and it goes and it says like, 150 megabyte cleaned, the rocket flies, whatever, and then it's like, you get like a present, and the president would say, we have something for you. Like, and you know, the conversion rate of that was insane, because you met the user in a very, very good psychological point. Later on, we sort of like, reversed engineer that, and we're like, oh, okay, so why does the user clean his phone? Because he's bored. They're bored, they're going to go to the cleaner, clean it, they have nothing to do, and then it's like, oh, yes, exactly, I wanted to play that game. Or, you know, I'm already in a state where I'm more open to see an ad. So I don't know where those points will happen in crypto. Like, I don't know yet, but this just requires like a lot of iteration, and once this happens, I think we'll be able to sort of like reverse engineer that and say like, oh yes, of course, when the user did this or that, it was the best time to show them some ad. Yeah, you want to?
Guess maybe to, thanks for that perspective. I think maybe what I wanted to suggest was that since Web3 allows you to more easily monetize, and oftentimes in Web2 anyways, I think it was kind of difficult to monetize. And just to make an example, there's like, you probably know Spindle, this like ad tech Web3 startup. They had an ad on CoinDesk today, and I actually failed to read the ad, to read the article on CoinDesk because it was full of ads, so I clicked away actually. So, and the reason that CoinDesk has all of these ads is because they need to pay the people that write the articles and maintain the site. And I guess what I'm saying is that, do you think that the ad space will continue to have this like huge role in like the web and tech and so on, or do you think, for example, that this will start to play less of a role, considering that everybody can now more easily monetize in other ways, you know, alternatively to running ads. Like Coindesk could sell NFTs, Coindesk could, I don't know, financialize with a token or whatever, so they would actually never have to sell ads and stuff like that, you know.
I mean, that kind of implies that ads are inherently a bad thing, which I don't think so. Like, I agree there are more ways to monetize, but still, if you're like a data play, like I don't take a website like DeepDAO or DeFi Llama, which is like, these are both great examples. They've built something super comprehensive, but how are they going to monetize this like in a reliable way? But something like DeFi Llama, if you go to check out the staking page, or if you go to check out the fundraising page, right, they'll be able to give you something that is fairly curated to probably what you need. So I think like to meet the user where he is at the right time is important, because people want to discover new applications. People want to do like more consumer stuff. And without that, we're going to be kind of stuck, in my opinion. So I think it should be, it should remain and yeah, grow and maybe, you know, be a bit better than what it is today. Yeah. Thank you.
All right. Thank you so much for amazing presentation. Next up, we have Edmond from Reality ETH, and he will be talking about homage to Augur, which is, I think, a prediction market.
Okay, thanks very much. So, this one. This one. How are we doing? One of these. One of these go. Okay, it doesn't seem to be going. Oh, you're going to start. Oh, okay. 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 So I'm going to be talking today about a dead prediction market, which I didn't build. So I run reality.eth, which is a crowdsourced smart contract oracle. I'm building a thing called Backstop Layer 2, which I will shill a little bit, but I'm mainly going to talk about Augur. So the fundamental problem that Augur is trying to solve, which has some very important design implications, is what we used to call at that time the Oracle problem, right? So the problem is, how do you settle a market? So for Augur, it was something like, who won the 2020 US presidential election? But this is, you know, so for them, it's very easy to make kind of a smart contract system to do all the trading, all the stuff that you do in a prediction market. But the fundamental problem of how you settle is this kind of serious crypto economic problem. So for them, it was a prediction market problem, but it has applications way, way beyond prediction markets. So anything where you need data from outside of the chain, right? Anytime you need truth on the chain, but also you have almost the same problem where you need kind of governance type of information. So I call it kind of truth and justice as the problem. So if you're trying to upgrade a contract and you need to know, is this upgrade malicious, then you've got just the same problem. So Eigenlayer now are calling this problem intersubjective work, by which they mean that there's information that everybody in the world knows, and people generally have a common idea of what the answer is, but the blockchain needs to know it. How does the blockchain know it? Okay? So I want to go through a few things that don't work, and these are things that are very widely practiced, sometimes for Oracle stuff, particularly for governance. And I'm going to go through a couple of things that don't work and then kind of build up to the Augur system that kind of does work, and then talk about maybe how we can improve on the limitations of it. So one thing you can do is token voting, right? So if you had the problem of, we've got a bunch of token holders, they have tokens in a prediction market, obviously they have an incentive to make that prediction market settle correctly, right? So when it comes to say who won the presidential election, they have the incentive to say it's Biden. The problem with this is, first of all, you can do a very simple, crude attack on it. You buy 51% of the tokens. Then you put a bunch of bets on Trump right at the end of the market when everybody realized that he'd lost. Then you use that to mis-settle, and you can steal all the money in the bets, right? But now that requires 51%, which obviously is quite a high hurdle. But you can also do much more kind of subtle things, like bribery attacks. And bribery attacks, in theory, can be very, very cheap. And they actually get worse, in a sense, the more decentralized you make them. Because if you're doing token voting, as an individual, the chances that your vote is actually going to flip the answer are not very high, right? So if you take the bribe and you vote to mis-settle the market, then it's likely that your vote will not actually swing it. Either it won't, the thing won't go through, it won't get mis-settled, and that will not cost you anything, so you'll get the bribe and nothing will go wrong. Or the other voters are going to vote to do it anyway. They're going to take the bribe, and then that will mean that even if you didn't take the bribe, you lose the value of the system, right? The system still breaks. So a decentralized system is kind of even worse from the point of view of token voting than a centralized system. If it's like 3 of us, it's much easier to coordinate. So then people might say, okay, let's add some incentives. Let's add token voting with slashing. The problem there is, okay, who are you going to slash, right? Who are you going to reward? Who are you going to punish? If you slash the minority, then you've kind of made the attacks even worse, because if the attacker can now just make a commitment that they are going to break the system, then the honest people are now incentivized to actually go with the attacker's dishonest solution. So, for example, you could make a contract that commits, that shows that you could pay the bribe, and say that if it goes through by a sufficient margin, you're not going to pay the bribe. So if you do that, then you get to reward the dishonest and punish the honest. So now we're going to get to the solution, which comes ultimately from Paul Stortz's paper Truthcoin, which I very recommend reading, which is we back the slashing with a fork. So what's going to happen is that if there is something that gets kind of escalated, I'll talk about escalation in a second, we're going to clone the entire prediction market and split the whole thing into 2. So there's going to be one prediction market which thinks that Donald Trump won the election, and there's going to be another prediction market which thinks that Joe Biden won the election. And the great thing about this is that we can probably assume that a prediction market that settles incorrectly is worthless. So the tokens on the version that says that Trump won aren't worth anything, and the tokens on the version that says that Biden won are worth probably as much as the prediction market was worth before the fork happened. So the great thing about this is that the token holder's skin is fully in the game, right? Because if they say that Trump won, they're going to end up on the Trump fork, and there's no need for anything kind of objective for the blockchain to know what happened, right? People know what happened, and people value the better prediction market. So Vitalik calls this subjectivocracy, this mechanism, and it's kind of also what secures the base layers, right? So if, for example, we have a censorship attack against Ethereum, and 51% of stakers decide that they're going to censor blocks, they're going to reorg out Tornado Cash transactions, then what we'll do is we'll make another version of Ethereum where they get slashed, right, socially slashed. And if we do that, then the people are just going to decide which version they want to use. They can use the censored version where their transactions aren't guaranteed to get through, or they can use the honest version, the uncensored version, where their transactions won't get through. So it's just this same mechanism that secures the base layers, gives us this very extreme level of security for securing this application on top of the base layer. A couple of problems with this. Firstly, forks are very socially expensive, right? So we can't just fork the system for every single market, and we'll have like 10,000 different augurs. So what we do here is we just use the forking as a backstop. So we use an escalation game. Reality ETH, by the way, is also an escalation game. It's not the one that Augie used, but it's the same mechanism. So people who pick one side are going to start by putting a little bit of money in. Somebody might say, I think Biden won, and here's a little bit of money I'm going to put in the system to back up my claim. Somebody else can then change that answer by putting up more money. In reality, if you have to double it, in Augur, it was this kind of custom series of dispute rounds. But anyway, so you get these ever larger rounds with ever larger commitments, And only when you get to a very high amount of money are you going to actually fork the system. So this worked really well in Augur as a backstop. There was never a need to actually fork the system. It never actually forked. And it was very good at correctly settling these prediction markets. Having said that, okay, but there's another problem, which is that the Augur users probably don't want to bet in Augur tokens, right? When we forked the prediction market, we were able to fork the Augur tokens, but they don't want to bet in those. They want to bet in Ether and DAI. And Augur can't fork Ether and DAI, right? So you need some kind of objective way for the blockchain to tell where should we put the Ether and DAI. So generally the forking, if the base layer forks, that's a subjective decision. People use whatever they want to use. But we have to get some objective choice about which one is better. So what the Augur guys did was they said the forkable token is the rep. You have to move your forkable token into one fork or the other. The majority will probably enter the most valuable fork. So then we can look at which has the most tokens going into it, and we can assume that's the truth. The problem is that now we've got an economic security bound. It's no longer a purely subjective system. Let's imagine that you've got $100 million worth of bets on Trump and Biden. And the Augur token is worth $10 million. Obviously, in that situation, it's still worth somebody's while to buy up half the Augur tokens or to do a bribery attack so that they can make the Ether and DAI go into the fork that says that Trump won, even though Biden won. So what they do in Augur is they say, we're going to make sure we never hit that economic security bound. So they're going to measure what they call the open interest, so how much money is at stake. That's continually measured. You also measure the governance token value, and if the open interest threatens to get half as high as the value of the governance token, then we're going to do something about it. And what we're going to do about it is either we're going to raise the fees. And by raising the fees, we're going to either reduce the amount of open interest because it will dissuade people from betting on the system, or it will maybe increase the value of the token because the token holders are getting this revenue that comes from the fees. So a couple of problems with this. And I should say, these are basically theoretical problems because Augur didn't fail for these reasons. Augur ultimately kind of didn't succeed in the marketplace, but it wasn't because of these. But if we're trying to use this mechanism more broadly, which I think we should be because it's kind of the only sound mechanism we have for governance, then there will be problems. So one is that these fees may actually be kind of impractical, right? So if you've got to make sure there's enough revenue coming in, people are incentivized to hold these tokens, and that's got to be, and the token value has got to stay half the whole market cap. That's quite a lot of money you may have to be paying in fees. And it may be that people just don't want to pay that many fees. If you look at probably a normal betting market, like a traditional bookmaker, will have a very small market cap compared to the amount of money they got in bets. That's generally how finance works. The other problem is parasitism. So somebody else can make a different market that avoids the fees, and they do the trading on their own market, and then at the end, when it comes time to settle the market, they just have a little market on Augur that nobody's betting on, and they read that off the Augur contract. So that way you can avoid the fees. This makes it even worse if you've had to raise the Augur fees, because potentially you then kind of push Augur into a death spiral where the token becomes increasingly worthless because it's going to get parasited off. And like I say, this is theoretical. This did not happen. The system worked. But we need to still worry about it. So that's basically what Augur did. I'm going to talk a little bit about alternatives and show my thing a little bit. One approach you might want to take is, what if we could make Ethereum forkable? Right? That would solve the problem. So we couldn't fork Ether and DAI, and that gave us this economic security bound. But if we could have forked Ether and DAI, then it would have worked, and we wouldn't have had to worry. So Martin Kopelman suggested this a long time ago, when Gnosis was still a prediction market platform. And but then what happened after that was that we had like the ETH ETC fork, and that made people kind of leery of like base layer forks. Justin Drake kind of suggested having like price feeds enshrined in Ethereum consensus. That would have had the same result, that if there was a dispute about the price feed, Ethereum would have forked. Eigenlayer version 1, not the new thing I just brought out, but Eigenlayer version 1, if it had become too big to fail, would plausibly have had this effect, right? So if people had attacked EigenLayer with all these staked ETH, and EigenLayer was very much used, then it's quite possible that we've ended up having a fork of Ethereum to figure it out. And this is why so many people got mad at EigenLayer when they tried to do this. EigenLayer version 2 is quite cool and interesting. They have kind of a solution to the parasite problem in that what they say is they kind of change the goal of the system. So instead of trying to get to the right answer, what they're going to do is they're going to allow people to insure against being on a fork with the wrong answer. And this means that if you haven't paid the insurance premium, then you may still get screwed. So this kind of may help with parasites. But it's potentially complex. I'd like to see how it works in practice. And it doesn't solve the basic cost issue that you need to be paying enough in fees to the to kind of the oracle to pay them not to steal your money when you're being governed by them. So just to say a little bit my thing, what we want to do is kind of more radical. So if we could fork Ethereum, that would solve the problem. But we can't fork Ethereum, so we want to make a new chain that we can fork, have that work as a layer 2 on top of Ethereum, so we have the maximum compatibility and the maximum composability with Ethereum, and any application on this chain will be able, after a sufficient escalation, to cause our chain to fork. And just like Augur, the forking is just a backstop. We don't expect it to happen all the time. It may well never happen, but having this backstop allows you to make crypto-economically secure governance and crypto-economically secure oracles with respect to assets that are native to that chain. If you want to bridge stuff from the layer 1 that can't be forked by this system, then you still have kind of an economic security bound, so you still have that limitation. Anyhow, so that's what we're doing about it. I've put a bunch of links on here. There's also a new design for Augur that Mikhail just came up with that I've hardly had time to process. And I've linked the Augur white paper there. I really would encourage everybody to read the Augur white paper, even if you're not interested in these mechanisms, even if you're not interested in this problem, just because it's such a good piece of work. It's very clear in laying out, you know, what are the problems that this solves, what are the limitations, what are the assumptions. Okay, and there's also some stuff about backstop and reality ETH, and also links to Paul Schwartz's paper, which I think is absolutely fundamental to a lot of what we do on Ethereum that he doesn't get enough credit for. Okay?
Does anyone have any questions?
Yeah.
So first of all, pardon me for not getting all the technical details from your talk, but I'm curious, what happens if the final decision is not clearly obvious in some cases, and there will remain people who believe in one decision, and then others will believe in another decision, and then maybe these forks will just grow and increase always?
Yep, so that's right. So you get an economic fork. It's the same thing that happened when, for example, when Ethereum and Ethereum Classic forked. Also, you know, some of the Bitcoin Cash forks, the same thing happened. I think generally what's going to happen is that it's going to end up fairly clearly on one side or the other. And the reason that usually happens is because there is a network effect that pushes things, right? So the same reason if you flip a coin, it hardly ever lands on its side, or like standing up. It normally falls one side or the other. So I think that's what's most likely to happen. But there is always the possibility that you will have an economic fork. And that has some consequences for like sort of DeFi stuff and things like that. That kind of weird things happen if your token split exactly in two. That can do kind of weird things. This is also something that may happen to Ethereum, right? I know people often, this hasn't happened for a while, so people are kind of designing systems kind of with the assumption that Ethereum won't fork. But you don't necessarily go into these things on purpose, right? And the only governance we have that governs Ethereum ultimately is the ability for users to decide whether to accept an upgrade or whether to reject an upgrade, right? We don't have democracy. We don't have a governance process in Ethereum beyond, you know, some researchers with various potential conflicts of interest deciding among themselves what to do, which may or may not represent the users. So these systems, I think, are only really secure if they can fork. Our system will have a greater likelihood of forking, and also a greater likelihood of forking in a bad way, in a sense, of getting one of those 50-50 forks, than the base layer. And that's why people don't want to do this to the base layer. But I think it's a price worth paying to get, like, you know, solid governance, solid oracles.
All right, I think that's all with the questions. Thank you. Thank you so much for an amazing presentation. Our next talk begins in 5 minutes. So yeah, let's resume at 3:15 p.m. Thank you. All right. So next up, we have Stephen from DM3, who is going to talk about how DM3's communication registry goes cross-chain on Genome.
Yeah, thank you very much for the introduction. I'm happy to be on DappCon again. I was here in the last DappCons as well. And today I'm going to talk about one side project of DM3, which is in connection with Gnosis Chain, especially with the name service Genome. And it's not only a side project, it's a project which also is very important for our registry. Yeah, today I first will start to talk a little bit about Web3 messaging, what it is and why we need it and what we should do, and then introduce shortly the DM3 protocol and show how the registry of the DM3 protocol is working and how we integrated Genome into this registry so that we now can use the DM3 protocol even on Genome or on the Gnosis chain natively. Yeah, why? Why do we need Web3 messaging? So all of us are using messengers, I think. So we are using messengers mostly in the Web2 world. And when we see these messengers, we can see these are closed systems, siloed data silos, or siloed data, and we cannot exchange messages from one of these messengers to another. And when we go to Web3 messaging, a lot of interesting solutions appeared in the last 1 or 2 years. We are using our keys, we are doing nice encryption so that we have secure messaging, we have privacy-preserving methods, but one thing didn't really change, and this is interoperability. And it means we have still solutions which are separated and they are own ecosystems. And with DM3, we want to change this. We want to build one connected ecosystem, and that's why we are focusing on methods that allow us not only to have secure and privacy-preserving communication, but also to have a protocol which allows interoperability. So what is Web3 messaging? So we are using our keys, which we already have in our wallets, to make secure communication. The user is not only owning its keys, he is also owning his own communications. So one thing which is very important is that we in Web3 messaging are focusing on decentralization. When we look at the existing messengers, we see that most of them are managed from a centralized service. And even many of the Web3-based messaging solutions still use a centralized service in between. And we think it's very important that we, in the same way we do it in other areas in Web3, that we have a decentralized organization of a messaging infrastructure. So that we don't have any single point of failures, there's no one who can control it, and so on. Encryption and privacy preserving, of course, is very important. We don't need to talk about unencrypted messaging. In Web3 messaging, of course, we are using well-known methods to have end-to-end encrypted messaging. We have end-to-end encrypted information. And also we should see that privacy is a very important thing and that we build solutions which are privacy preserving. When we look to the Web2 world, we see that we have big ones, so big messengers, and the goal of these messengers is to grow and hopefully be a monopolistic solution for this type of communications. In Web3, we learned that diversity is a good thing. So when we look at clients, for instance, for Ethereum, we have a diversity of clients, and we did see it's really good to have a diversity there so that we have a more secure ecosystem, and also that when we look to messaging, that we can build solutions which are focused on different communities and then have special functions which are good for this community but are not interesting for others. But when we have diversity, we need interoperability because there's no one-fits-all tool, and interoperability allows the user to decide what messaging solution is the best fitting for his or her needs, and then nevertheless can communicate with anybody else. And another problem we are focusing on is spam protection. When we look to the Web 2 world, or we can start with the Web 1 world, email, we see that spam is a real great problem. And even with messengers in the Web 2 world, we have a lot of spam information coming to these messengers. And with Web 3 mechanisms, we have a really great tool on the hand to build a really secure spam protection mechanism which can solve the spam problem. So, but when we see all these things we can do with Web3 technology in the messaging area, what are the really essential points we have to focus when we build such a protocol? So the first is we need a central but decentralized registry for the communication information. That means if I want to send an encrypted message to someone, I need a registry where I can look up for the keys I need for the encryption and the information how to deliver the information. Then I need a decentralized network which I can use to deliver the messages, which has no intermediates, which has no censorship possibilities, and which also can connect to other networks as well. And yeah, interoperability, from our point of view, it's very important so that we can grow the Web3 messaging ecosystem so that we not work as small silos as it is done until now, but that we can build this connected ecosystem. When we started building the DiEM3 protocol, which is an open source and public good protocol which should be supported and can be used by the community for free, so our focus was not to replace all the existing solutions, but to connect. There are a lot of interesting good solutions right now existing, and it is not a practical way to see that we all these solutions can replace with a new solution. But what can happen is that we can connect these and build an ecosystem which helps all the users which are in this ecosystem. So what are the characteristics of the DiEM3 network? So it is a decentralized network which is scalable, which allows messages to be transferred. We focus, as I said, on interoperability and have these spam protection rules integrated. And we have this central registry, which allows to find communication profiles from others on one place. And for this registry, we are using ENS, so that everyone who has an ENS name can just put his profile to this name, and then it's easy to find it. And here, today, I will talk about how we can extend this registry, not only living on ENS, but also living on other chains or on other sources. About the message relay network, I already talked. So this is a decentralized network which scales because it's not gossiping all the messages from node to node, but is there to have relays for messages when I send it to someone. And the DiEM3 token is used to focus on a lot of these functions inside the network and help to govern the network and the development of the DiEM3 protocol. I don't want to talk a lot about the architecture of the protocol. There are a lot of different modules so that every perspective of messaging solutions have a module which can be used to do this. Today, I only want to focus on a small part of it, and this is the part of the layer 2 registry, which means this is the part where we link other resources to our ENS-based registry so that we can use these sources also to store the information and extend the network to other ecosystems as well. So how is the DiEM3 registry working? As I said before, it is a central but a trustless and permissionless registry. Using Web3 technology, in this case ENS, we have a tool where everybody can put information in it and everybody can read this information. So in this, it's completely decentralized because ENS is living on the Ethereum blockchain, and we have all the things we need to have this decentralized access. So what is stored in this registry? First, we store the public keys for the encryption and for the signatures. So signatures, we need to prove that a message is coming from one person, and encryption, clear, we need end-to-end encryption in the very first place. And another information is also stored, which is the delivery information. So every user can decide which nodes he is connected to and listening to, so that if I want to send a message to him, I can read the registry and see, okay, I need to send it to one of these nodes. And also these delivery service nodes, these message relay nodes, they have also an entry in this registry, so that we also can find the keys for encryption and signatures for these nodes, and also the URLs how to connect to these servers. And these information are stored as text information in ENS, so you have a special text record there so that it's easy to access it and to work with this. But what is the problem if we only use ENS for this? It's nice, everyone who has an ENS name can use it, but ENS lives on layer 1, and that's why it might be expensive to publish a profile on ENS, because when the gas price is high and we have to publish this text record on ENS, it's quite expensive. Then there are also other name services, like Genome, which is living on the Gnosis chain, and there are also ecosystems which need to use these name service and want to have the profiles stored there. In DM3, we solve this problem by having resolvers for other data sources, so that we can link any data source to an ENS subdomain. So that means I can link any layer 2 to this domain, I can link other chains like Gnosis to it, I can even use decentralized identities and link the information to a subdomain of ENS. And also, we can connect to centralized services, which have stored their registry on a cloud service, but we can now link this also to an ENS subdomain, and with this, it's easy to access it, because we have only one source of truth, and this is ENS. So how is this done? We are using CCIP, the cross-chain interoperability protocol, so that we can get information from other chains or from other sources and have them available and verifiable on layer 1. So how is this working? So I would take the smart contract and ask for information. In our case, we ask for this text record in ENS. And if this text record is existing on layer 1, we get the result. If not, the transaction is reverted, and we get the information that the real information is on another source, and we know now, okay, here I have the information or the URL where I can acquire this original information, and I have the information how to prove it. So then I go to this gateway, get this information. In the case of Genome, I would require or get the information from the Gnosis chain, and then I get also the proof or the verification that this information is correct. And with this, both informations, the original information and the proof, I go back to the layer 1 smart contract and check if this information is correct. And with this, I have on layer 1 a verification that I have read the correct information from another place. So how is this looking in Genome? In Genome, you can get your own GNO domain names. Let's say your name.gno. And then we have these connectors and these resolvers so that we can go to ENS, and all genome names are now connected to a gnosis.eth name as well. So when I have the name alpha.gno, then I have in the same time alpha.gnosis.eth on ENS. And with this, we have one source where we can look for the information, which is ENS, but I also can use the genome name service and look or read the information from this chain as well. So how is DM3 now using this? The only position where we really need to connect to Gnosis chain is when we publish the profile. That means the user can decide on which name service, in which data storage he wants to store the information, and then it's published to Genome, it's published to Layer 1 or to any other source. And when a user wants to send a message to a GNO name, then we can look into ENS because we know that what the connection is. So we have an alias, top-level alias system that we know GNO names are connected to gnosis.eth names. And this we can read, and then we find the profile on the ENS, read the DM3 profile, and send the message. And with this, we can use Gnosis domains right natively because they are connected to the ENS system, and with this connected to our registry. So let me conclude what we have talked about today. With Web3 messaging, we have very interesting methods that we can build a decentralized messaging ecosystem, and especially when we are focusing on interoperability, we can connect existing and new solutions so that we can build this connected Web3 messaging ecosystem and also integrate Web2 messaging in the future. So as I said, interoperability is essential because only if we work together, we can build such an ecosystem. And with the CCIP resolvers, we can connect any data source like the genome name service to ENS, and with this have one source where we can access the information. The CCIP resolvers we have developed for this are not only focused on ENS, they can, or focused on the DM3 use case, they can of course be used for any other information as well. So that if there's a project which needs information from other chains, they can use this CCIP resolver approach and do it in the same way. The solution is live. You can go to dmc.chat and test it. If you have a genome name, you can directly publish your profile there, and then you are available on this name as well. What else can you do? The DM3 group is open to that you can join this initiative that we start to build an interoperable messaging ecosystem. Our components are available. You can use the components to integrate it in your applications. You can build on top of the protocol, and you can use the ecosystems we have connected so that these are available for you as well. Thank you very much.
All right, thank you so much for an amazing presentation. We'll resume at 3:40 p.m. with our next talk. All right, everyone. Now, next up, we have Slava from gRPC, who's going to talk about RPC centralization in Web3, rebalancing efficiency and decentralization.
Hey, everyone. Okay, so today I want to talk with you about RPC centralization and what it means for our industry. So just to introduce myself, my name is Slava, I'm CTO at gRPC, and we're building decentralized RPC infrastructure for the multi-chain future. So, what's RPC again? Maybe you haven't heard about it, but if you haven't heard about it, you probably heard about blockchains. And if you know, blockchains are probably it's just a fancy way to synchronize state between different computers in a decentralized and permissionless fashion. But the most important stuff in blockchain is the state. So if you're building any kind of Dapp or Web3 application, you need to access this state. So typically, each blockchain client has some kind of API that allows you to query this state. And why do we call this RPC? Because it's like API. Well, historically, Ethereum and Bitcoin went with JSON RPC protocol, and the term kind of stuck. So originally, of course, everyone imagined that if you want to write your own Dapp, you would just run your own node. And this is a perfectly decentralized way to do stuff. However, we live in 2024, and this is a multi-chain future where running, if you support 30 protocols, running all the blockchain nodes is just not feasible. It's too expensive, and basically nobody does that. So naturally, a type of company appeared that we call right now RPC providers that are basically typical software as a service company, Web2, web software as a service companies. So we're building decentralized web on top of centralized software as a service company, but temporarily, right? Well, let's try to think about it. And first, let's ask ourselves a question. What do those RPC customers, clients want? Well, they, of course, want good user experience and developer experience, high speed, high reliability, and low cost. So what things they don't want? They actually don't want decentralization, and they don't want fancy technology with bad developer experience. And it's understandable because, we're talking about Web3 companies. They have their own customers, and they should care about them. And, they can't say, last day we were down for 3 hours because of our RPC provider, but, it's decentralized. Their customers will probably go to their competitors that can probably use centralized providers. So centralization on RPC layer is a status quo. It's not because we are bad industry or bad people. It's just because it's the most efficient and easiest way to achieve desired properties that customers want. Okay, but why would we even want decentralized RPC? And let's try to be honest about that. Well, maybe user experience and developer experience for decentralized RPCs is better. You probably know the answers, that decentralized RPCs historically perform in terms of user experience very bad, and centralized RPCs and, in general, centralized applications have better UX and DX. Okay, so that's not it. Maybe they have better reliability. Well, there is an argument that decentralized RPC providers are kind of running for a while right now, that we decentralized RPC providers don't have a single point of failure, so we're more reliable. But unfortunately, every decentralized RPC provider I know also runs centralized gateway. So it's kind of, effectively the same thing as with centralized ones. Again, it's not because we want to lie to you. It's just because everyone wants good developer experience, and it means they just want to copy-paste the link from your website, and that's why we need centralized gateways. Okay, so maybe decentralized RPC providers have better performance. Again, you could argue maybe that in decentralized protocol you can have on board a lot of projects from all around the globe, have better latency, but I would argue that centralized providers can do it too, can have servers everywhere, and in theory they can even reach better performance than decentralized because they control everything. They control hardware and networking, and then can build a setup that is, in theory, more performant than the centralized one. Then there's verifiability. It's a common argument in the discussion between centralized versus decentralized RPC provider. And the core thing is that when you use some kind of RPC provider, you kind of trust them. Because you don't have any means to easily verify their response. So nobody cares a lot about that until, of course, something bad can happen. For example, one day you go to some very important project, very important vote, and in this moment, our RPC provider decides to tamper with the data and, for example, change the voting title. And you can end up voting for the thing you don't understand or don't agree with. There are a number of ways how you can protect yourself. First and obvious one is light clients. So light client is a super efficient node that you can run on your phone, run on your in your browser, and you basically can use it as a RPC node for your Dapp. You connect to this light client, and this light client connects to your RPC provider. But it does some fancy stuff that allows it to verify each RPC provider response. So you kind of protect it from this tampering. There are existing solutions right now for Ethereum. Two of them are Kevlar and Helios. However, there are a number of problems with them. First, as I said, when you send a request to light client, it translates your request probably into several requests. And this will be more expensive for you. It will take more time. And so a lot of applications do not want that. Also, of course, not all requests can be verified this way. And the last thing is not all the blockchains support light clients. Ethereum does, but many more don't. You can imagine some solution using ZK magic. Probably you can imagine that our RPC provider can send the ZK proof along with the response, and you can verify it. However, technology is not yet there. It's computationally infeasible. And I struggle to imagine how it can be done universally across all blockchains. And the last one, quorum check. You kind of can send the same request to different RPC providers, check if they agree with each other, and if they do, probably their response is correct. So you can see all of those three ways to battle this verifiability problem. However, it doesn't matter whether you work with decentralized or with centralized provider. It works either way. You can argue that in decentralized setup, you kind of can punish the providers who try to lie to you. However, it's not really important in my opinion. So far, things don't look good for decentralized RPC providers. So what about cost efficiency? And I would argue cost efficiency is really better for the centralized providers. There are several reasons to that. First is that when you have this decentralized RPC provider, there's basically a protocol, and there's protocol participants, node runners, who run their nodes for you and participate in the protocol, and they can squeeze more juice from their setup because, for example, they can participate in several protocols simultaneously and use different resources. For example, their server can have GPU, CPU, and they run the node, participate in graph indexing, and maybe some GPU sharing stuff. So the second one is if you have any kind of price auctioning inside a protocol, you can have significantly more efficient price discovery mechanism because all of those node runners will compete with each other. Yeah, the centralized providers also compete on price. However, the problem is that there are not a lot of them. And the thing is that it's not always about price. There's general stickiness to the platform. There's BD, there's marketing, PR, all that stuff. So the price discovery mechanisms will never be as efficient. OK, so what about multi-chain? Does multi-chain better for decentralized RPC providers? Yes. The thing is that when you are a centralized RPC provider and you want to onboard new blockchain, you need to first rent some servers or buy them. Then you need to learn how to run this new blockchain stuff. And then you need to add some code to your UX and your load balancer to support the new protocol. However, in decentralized RPC provider, we just need to support this protocol on load balancer level, and that's it. And then we can find some people who are already running those nodes, or at least know how to run them, or at least have some spare time to learn it. So that's why this is why we were able to support 63, I think, blockchains right now, far more than any RPC provider on the market right now. And the last and most important thing, in my opinion, is censorship. And you know, censorship on RPC layer is not unheard of. We've seen instances of that already, but I argue that it's getting worse. So there is a recent paper from a group of legal researchers that they want to provide a framework for battling illicit flows, illicit activity in DeFi. And they argue that, in TradFi, battling illicit activity is all about intermediaries. So you can implement some measures on intermediaries, and if you control intermediaries, you kind of control illicit flows. And they correctly identify that RPC node in DeFi is the ultimate intermediary. All read and write requests go through it. So they define CCT, critical communication transmitter. Basically, every commercial RPC provider should be CCT, and then you can require them to implement risk management practices and procedural reasonable design to help mitigate illicit finance activity in ways tailored to their operations, which is basically implement censorship mechanism. Can it work? Well, first I must say that battling illicit activity in DeFi is a noble goal. However, imagine there is a hacker and they want, they stole some money from the protocol and they need to send few transactions. Would it be hard for them to run their own node or find uncensoring node? I would argue no. But if you're a big DEX or a big Web3 application, it can be hard for you to, mitigate this censorship. So you would have 3 options: run your own nodes, use unregulated providers, or submit to censorship. And we know, like we previously talked, that running your own nodes, if you support 30 blockchains, is not viable. It will probably kill most of the project that will try to do that. So then there's only 2 options: running unregulated providers or submitting to censorship. And it's hard to say how it will play out. However, remember, in RPC market, everything is about performance, reliability, stuff like that. So market leaders who excel at this, they will probably comply immediately. So you are left with those who are worse in many ways. Privacy, security, all that stuff will be worse for the unregulated providers. You can compare this with the, for example, free VPN situation, where you can use free VPN, but they will gather data about you and sell it to someone. So maybe the only way will be just something to censorship. And again, for centralized providers, there's actually not a question to comply or not. They will eventually comply, maybe just comply or cease operations in country of regulations. However, for decentralized providers, it's a little bit more complicated. Remember, there are node runners, and they can decide for themselves. And you could argue, yeah, but you have centralized gateway, and if it will implement censorship, it doesn't matter. However, if you have a community of node runners unified by a protocol, you can have multiple gateways. Some of them will be censoring, some of them will be not. And you can compare this to situation in Ethereum block, transaction censorship. It's enough to have just a small fraction of non-censoring MAV relays, non-censoring block producers to non-compliant transactions to pass through. So if we will have at least 10–20% of node runners and gateways to be non-censoring, this will make those regulations inefficient. Okay, so let's look at everything we discussed so far. So if we're building decentralized RPC provider, we probably have better cost efficiency, we have better multi-chain, and of course we have censorship resistance. Verifiability goes both ways, and for centralized providers you have better UX, DX, better performance, and better reliability. And if you remember what I was talking in the beginning, centralized providers are actually winning hard. So if we don't do anything, we have a future with extreme centralization and censorship mechanisms. So what can we do about it? Well, the real question is, can we get everything? Can we get best of the both worlds? Censorship resistance from decentralized world and good metrics from centralized world. That's what we're exploring at DRPC. So our goal is to understand whether we can build a decentralized RPC provider that is on par or better than our centralized counterparts. That's why we, for example, focused more on the gateway. We saw some project that already built permissionless, decentralized node runner set, and we know it's possible to do that. However, we decided to invest more resources into a centralized gateway that will be able to offset individual provider problems, optimize latency, reliability, stuff like that. And I would say that we have a proof of the concept working, and we were able to onboard a lot of cool projects like SushiSwap, InstaDapp, Lido, and many more. And they all choose us not because like we're decentralized and we gain some points from it. It's just because we're better, or at least in some ways better than their previous RPC provider. So yeah. Now our goal to understand how we can push decentralization even further, but we don't want to do it, just for the sake of decentralization. We want to understand if it's possible to push decentralization further without compromising quality of service. Because in my opinion, the only way we can have a future with truly decentralized web running on truly decentralized data layer is this way. So we're trying to build this future at DRPC. And if you want to check it out, go to drpc.org. If you want to follow our Twitter account, you can scan the QR code. That's it for me. If you have any questions, I'm happy to answer.
All right, I think no questions? Okay, thank you so much for an amazing talk, Slava, and we will continue at 4:35 p.m. Thank you.
here. We're going to be with the next talk by Mike Krupin from Block Scout, talking about Dapp security, creating a trusted Web3 space. Welcome.
Okay, here's a little bit problem, no? Okay, yeah, so today we will talk about the most, I think one of the most important problem and topic in the Web3 area at all. It's about the security and trust, especially with decentralized apps. But before we starting, I will introduce a bit the project that I'm working with my team on. So it's Block Scout. It's an open source explorer. Many of different chains can use it like any times for their own chains. As well, we help them to host their infrastructure, and if they don't want to like do any like work on Explorer on their own, we can help them with this one. And in addition to open source Explorer, we have different vectors like directions of development. Like we are working on marketplaces. We are trying to like simplify the like interaction with transactions on blockchain, trying to just entrepreneur them, and many other stuff. So let's back to our topic, and the first question is like, what is the biggest problem in Web3 right now? And it's to be true, like it's not so simple question, but I think it's obvious. It's because like many of users can be hacked and scammed every day by anyone, by projects, by NFT collections, by anyone. So this is one of the biggest problem that we have right now. And we can see like many different examples how it happened, like 1, 2, 3, 4, many of them, and people lose their money because of hacks, especially because of hacks on and exploits on smart contracts. And if we can check the tendency, then we can see that this tendency of hacks is pretty the same. But of course, like there is a decreasing of the number of losses that that were stolen. It's something good, but as I said, the tendency is pretty the same. And if you go deeper inside all these hacks and what happened, we can see that most of assets were stolen from DeFi platforms, so 63%. And many of hacks also happened on DeFi platforms, so it's 50%. And all this data from Crime Report by Chainlink. If we go one more time deeper, we can see that most of like hacks and primary target of attackers are smart contracts. Almost like 30% of all attacks happened with smart contracts. There are like different categories of attacks, like vulnerabilities directly on smart contracts of a specific protocol, or if attackers trying to find the vulnerability of another protocol to hack another protocol. So yeah. If we can see, we can see here that around $2 million were stolen on chain because of different vectors of attack on smart contracts, and this is a big problem. Yeah, for now I just want like quickly go to wormhole hack just to understand like more deeply what happened with this kind of attacks and hacks. So yeah, wormhole is a like a breach protocol that helps like to breach their assets, users' assets. And there was a hack, there was a hack that where users lose their like a lot of money, to be true. And what happened is that like the one of the key thing in wormhole protocol was like a breach smart contract, and this smart contract has their own like guardian. Like a guardian cryptographic that checking cryptographic signatures, and the main attack was exactly on this smart contract. What they did, they created a fake cryptographic fake cryptographic signature and used it for these guardians. And these guardians check false check security, bypassing check security of this signature. And because of this, they could mint WETH and then bridge it to mainnet and then withdraw their ETH tokens. This happened in a couple of, I don't remember, this year or maybe 1 year ago. And because of this, users lost around $200 million. It's pretty big amount, especially for users who are just irregular users. And as I said, the main focus, one of the main focus for BlockScout was to create a trusted and secure space for regular users who are just they can just open one place, get information about the apps and other stuff. So it's and they will trust the space. That's why we're starting to work. That's why I started to work on DappScout. So it's the place where we try to aggregate as more as possible different information on-chain and off-chain and give a user a really simple report or a score about the security of a specific protocol. So the idea is pretty simple: aggregate information and show something simple to a user. And when a user tries to find an app for a specific use case, for example, for a swap, to make a swap of token on one chain, they can go to our marketplace. They can click on a swap category and get the list of all apps and sort them by security score. This security score is, we are getting it by checking all contracts, all smart contracts of a specific protocol and checking them through a solidity scan. So solidity scan has different validators divided by different categories. So they are just checking different aspects of every smart contracts and just show a security level of the specific smart contracts. And we are just aggregating this information and showing it as a simple report here. In addition to all this information, we're also showing the list of total number of smart contracts as well as number of verified contracts. Yeah, so it's pretty useful information, and it's something that can help users to understand what they can use. And in addition to all of this, users also can interact with this specific, DApp directly on our platform. And in addition to all of this, they also can forget about reconnecting wallet every time, because they need to connect it just once to BlockScout, and then it will be automatically connect every time to all apps. Also, users can get quick access to all information about the protocol, like social links, description, security information, smart contracts, and also a bit later there will be information about a social input from other users about this specific app. And as I said previously, one of our hypotheses that if we are collecting as more as possible different information about the app, on-chain, off-chain data, then we can create a more trusted and secure space for the app. So it's some kind of profile of the app. Yeah, and as I also mentioned a couple of minutes ago, that we're also working on a social input for our marketplace. So the idea is here that we want to aggregate information like feedbacks, ratings, reviews from users, but not from all users. We want to add only users, only reviews and ratings from users who interacted with at least one smart contract of a specific app. So this can help to filter some bots or just fake reviews. And also, in addition to this one, we are working closely with open languages to try to use their graphs and get information about reputable users to show them at the top of these ratings and reviews, so users can see a familiar faces from Warpcast, for example, from Lens, and get information and reviews from them. Exactly.
And also, like in addition to ratings and reviews, we also want to show some basic analytics for specific apps, because it's also one of the important piece of information that shows the user the popularity of the protocol, and he also can understand, like, should I use it or not? So that is what we are doing right now. We are as I said, we are collecting all possible information to give a user like a app store in Web3, so they can just go in it, discover different apps for their use cases, and just get as more information as possible and solve and decide for themselves, like if they want to use this specific app or not. Yeah, so thank you very much. Yeah, if you want yes, if you have any ideas regarding how we can improve our services, if you have any questions, feel free to contact me here, and also subscribe, follow us on Twitter, yeah, and get information on our website.
Super. Thank you, Mike. Now, if any of you have any questions, we have 5 minutes for some Q&A. Front. Oh, just 1 minute that we get the mic.
Hi, and I'm a sponsor of Block7 on GitHub, by the way. I've been a big fan of the product. What's the demand you're seeing for the Dapp marketplace so far? Are you observing the Dapp's buying into the narrative of decentralized front ends?
Yeah, it was one of the hypotheses that we are trying to focus a couple of months ago to offer them the centralized front-end hosting. But we faced many different issues with settings, because like every project has their own settings, environment variables, and other stuff. So we are just launched a couple of such cases with several apps. The most demand for now that like we got from service with our users is that the top 3 important stuff when they're interacting with the apps is like security. So to get information, what, like, is it secured app or not? Like, it's just some abstract, but we are experimenting with this information. And also the second thing is to get as more information, like, from real users. It's like reviews, ratings, and maybe not ratings, but mostly reviews, just to understand like what users think about other the apps that they interacted with. So that's why we are creating a marketplace, like for this case, for example. And also it's also useful place for small chains, especially like when we help, when Block Scout helps to deploy small chains. This marketplace is the place where users of these chains can go and find like what apps are available here on these chains. So it's some kind of DeFi Llama 4 or the app Radar for small chains, something useful in this case as well.
Thank you. Any other questions? Oh, sorry, Vanishka. A minute. Thank you.
How are the applications included in your Dapp Scout?
Yeah, we have, I think, 3 or 2 main like inputs how we can include these apps to our marketplace. The first one, we're just discovering and trying to find something interesting, some new apps that we can include manually. Also, any of projects can go to our marketplace and just like submit information about their app, and we review it and include to our marketplace as well. And sometimes our partners or chains, they're also contacting us, so we can add this information to our marketplace. Yeah, and also like we have is the fourth place how users can add their projects. We have a submit idea button, so everyone can also like offer their ideas regarding what they want to see in our marketplace. Yeah, so these things.
Super. Any other questions? We still have some time. Okay, here in the front.
Curious about the process of leaving reviews. you could theoretically still spin up bots that do at least one interactions on each smart contracts, and then they just leave reviews. How are you planning to solve that?
Yeah, it's a good question. Yeah, so I think like in the first version, we are just launching this reviews. As I said, like just if a user interacted with like an address interacted with this specific like one of the contracts, then he can leave reviews. But then we'll just need to check the tendency if there will be like such cases that you described. And then I don't know, like we can introduce some kind of timeout for such reviews. So only like users, one address per day can leave their like reviews. But I understand, yeah, that could be like many of different addresses. Yeah, it's a good question. I will write it down. Yeah, it's a good point. Yeah, interesting. Because like the only thing that we saw the user flow that they need to connect a wallet, and when they publish their reviews, they need to sign the message. So this kind of things and the criteria that they need to interact with a smart contract. But yeah, also like we can use some that you offered like GitHub Passport, but it shouldn't be something crazy like just to read their reviews. So it should be something simple, but at the same time it should be useful. So just to filter out some bots and spams. Yeah, agree.
Well, thank you guys. We're gonna take a little break and we're gonna start over at 5. So I'll see you guys in a bit. Thank you.
Thank you.
Okay, guys. So up next is Annette Relikova from Last. I hope I'm pronouncing it correctly. Talking about utility chain, the last network services layer. Welcome.
Thank you. Hello. Okay. Thank you. Welcome, everybody. I'm just thinking mic check. Okay. Let's talk. Let's start my talk. Okay. Hi, everybody. Welcome to my talk. Today, I'm going to talk about utility chain, the last network service layer. Oh, okay, this works. So, hello, DappCon builders. I'm very happy to be here on behalf of Last. My name is Annette, and I work as DevRel at Last Network, which is the cash flow reinvestment layer 2. And I'm very excited to talk about the utility chains and the blockchains as a service layers. And I'm very happy for those of you who stayed here for my talk, although it's kind of late during the day, and I know that there is a lot of things happening tonight. By the way, production crew, the timer is not counting. It's like started, so I'm not sure what's wrong there. But anyway, let's talk about the utility chains. So blockchains are crucial in terms of how we look at the blockchains when it comes to decentralization. They're the crucial component and crucial part of how we look at decentralization, how we look at the utilities. They're crucial in terms of scalability and essentially sustainability. The sustainability of the assets is the most important part of the blockchains, and that's where we found the key point in like what we are solving at Last. Especially is blockchains are amazing from the economic perspectives. They are great for like the ecosystem and for the way how we use blockchains as a DeFi solution in like DeFi. And they're like blockchains are giving us new opportunities, what we do with money. And they're just like, you know, blockchains are not only DeFi, but they're very crucial in DeFi as well. So the layer one blockchains have many different utilities. They mainly produce blocks, they finalize transactions, they do have a native token for transaction fees. They are the main layer for the security. So like the layer one blockchains such as Ethereum or Bitcoin or even Cosmos or like pretty much like any other layer one that you like, they are sort of like the driver for the liquidity. They're awesome. They have pretty decent developer experience, but they have kind of high fees. And especially when it comes to blockchain, we see the users like to just like go to like find like another solution when it comes to high fees, and they also don't have the best transaction throughput as well. So those layer one blockchains, you know, as I mentioned before, those can be Bitcoin, Ethereum, Cosmos, and there are like many other layer one blockchains, and they have those basic structures and they have the basic utilities, how they work. They're all awesome, but the high fees is the breaking point. That's why we have rollups as a scalability solution for blockchains, and rollups are out there supposed to help us figure out the scalability issues and the way how they work. They process the transactions off-chain. So they like batch transactions, they process them off-chain, they have a thread proofs for transaction execution, they have a data availability for transactions as well, and essentially they are interoperable. So they connect or they essentially roll back to the layer one, which provides the highest security, but essentially they execute off-chain. Layer 2 blockchains are also very good source for how protocol makes money. So data availability, so rollups, essentially they take transaction fees, and of the transaction fees, they make money. And that's like all awesome. but that's why there are so many layer 2s, because they're an amazing way how protocols can earn more money. And that's not very sustainable. So, because when it comes to sustainability, what we want, especially in terms of optimistic rollups, we want like builders to get paid, and we want users to get paid as well. So, which is like kind of cool, but at the same time, it's not the most optimal way how the cash flow flows into the system and how the cash flow is getting through the system. So, we don't want the teams that are building layer 2s to only make money. Like the builders are the ones who deserve to earn yield, and the builders and users are the ones who should make money itself when it comes to layer 2s and rollups itself. So that's why Optimism and Arbitrum is a great example, but they roll their transactions essentially to the layer 1s, but they are the ones who make money, and that's not exactly how the layer 2s become sustainable. So what we do at last, or what we are trying to achieve, is we are taking the yield that is coming from multiple layer 1s, and we plug it into essentially in the end into the layer 2, and we do that through the twin chain mechanism. So the twin chain network mechanism works in a kind of very cool way. So we have a utility chain which works as a service layer, and we have an EVM plus based layer 2 for applications. And the utility chain acts as the centralized bridge and accounting layer. It also has a TSS threshold signature scheme in it, which makes it more decentralized and much more secure. It's mainly the layer 2s are mainly just multi-sig, and multi-sigs are not really safe, and the threshold signature schemes are rotating the keys around the validators and operators. The utility chain itself is the layer that developers don't interact with. It's mainly just for the operators and for validators. It is the centralized consensus layer for cash flow accounting and the centralized bridge between multiple layer 1s. The layer 1s is where the yield is coming from and where the liquidity is coming from. This also opens up variety, or huge opportunity for more features to be added as well to the network. And we're very excited to introduce this new component or this new network principle. Then the layer 2, the EVM plus base layer 2, is the execution environment for application. It also has a data availability marketplace, native incentives, and customizable gas fee marketplace. These are all the features that will be added, and those are all awesome features that we have at last. The EVM plus base layer 2 is built from Arbitrum stack, and we are utilizing Stylus framework. Stylus framework is developed by Arbitrum, and it is much more efficient comparing to Solidity, as Stylus framework is supporting Rust, C, and C++, and other native languages that are much more efficient when it comes to developing applications on Ethereum comparing to just basic Solidity, which is kind of cool, but at the same time, we want the applications to be much more efficient than the Solidity, when it comparing to applications developed in Solidity itself. So at Last Network, we are supporting builders. We want builders to get paid. We want the users to get paid from the chain revenues. The chain itself makes money, and we want the users and builders to take advantage of that. And we believe that users and builders are deserve to be paid, not just the layer 2s to make money out of it, and not the protocol itself only making money of the protocol itself. So last protocol is built to optimize profits from sustainable resources. There are many different resources where the users can make money from, but essentially we want to support builders and users on its journey and develop them. There are a couple different resources where the yield is coming from and where the revenue itself is coming from before it's distributed back to builders. So we take a resource from yield-bearing assets that are coming in from users. We also take, it's also coming from sequencer fees, profits from autocan emissions, native swap market fee, and as well as many different places. At last, as this new unique protocol design opens up doors to many different ways how we can utilize the yield and where the yield can come from, and it will be distributed straight back to the builders and users through many different options. Also, this is my last slide. I know that I'm probably going a little bit faster than I should, but I wanted to end quickly since it's almost end of the day, and I wanted to give you all as well opportunity for questions. But I wanted to give you a little sneak peek as upcoming conferences where the last team will be is Austin, and we will be also having great presence in Brussels. And in Brussels, get excited as we are doing a barn there. Feel free to grab my contact if this presentation or like anything sounded interesting. Follow last, and we are excited to bring more opportunities, more like cash flow or investment possibilities out there. And just to give you a little timeline, we are currently building our failnet, and we are planning to launch our incentivized testnet in summer. And that's it. Thank you.
Super. Thank you, Annette. We have 5 minutes for questions, if anyone has one. Then I will see you in 5 minutes. Thank you very much, Annette.
Thank you. Bye.
we have Philip Pieper from Swarm talking about with tokenization of real-world assets and cash on the rise, how can stablecoin issuers remain relevant? Welcome, Philip. Thank you.
Thank you so much. Welcome at the end of the day. We know it's been a long day, but I'm going to bore you with one more topic that is related to what the title had said. I think real-world assets, just basically as a precursor, is obviously defined as anything that is not chain native, represented actually on a chain. And I would argue that, aside from the digital native assets, that's the bigger use case that we're actually trying to solve for blockchain entirely. That's why it's not really a surprise that real-world assets as a narrative has become so strong in this bull market, because it will lead eventually to all the different shapes and forms how blockchain manifests itself into our lives. And I would argue that stablecoins probably are the most successful use case for RWAs today. It's actually representing cash, hopefully, in most cases, that are then digitized. So when talking about RWAs, I think there's been a lot of difficult things that have been getting out of the way. So it's been always this long promise coming for the last 7 years of how to use blockchain-based processes to actually show something that is relating to the outside world on a chain. But one of the linchpins that I want to talk about today is actually the way how to create liquidity for it and the difficulty about it. So, maybe short intro. Myself, I've been a serial entrepreneur. I did different companies in the digital asset space, but most importantly, also was working in my former life in the financial industry for Deutsche Bank and Allianz Group. And then in 2017, we started actually with the first DAO way to actually build compliance-based smart contracts in a time when obviously sort of the ecosystem was not really familiar with what it means to actually do sort of regulatory compliant token offerings. So that led to the first iteration of Swarm, which then in 2019, we actually transitioned over to Europe. And are headquartered out of Berlin. We actually interacted for the last 4 years with the German finance ministry and with different institutions in Germany and across Europe to actually help build the regulatory footprint of actually being able to do this. So as of today, we have 2 businesses, which I'm not going to talk about too detailed here. One business is actually sort of when we publicly actually tokenized public stocks and bonds, so T-bills and MicroStrategy and Coin as digital assets that you can then actually sort of purchase from your MetaMask wallet on a sort of permissionless system. And the second business is then using the entire stack of the tokenization stack, so the token issuance as well as the trading stack, to then actually give that to issuance platforms, to issuers themselves, etc. But one of the key challenges has always been actually what does it mean in terms of liquidity? Because issuance is pretty easy. You can actually do that. It's almost like a commodity. You can do it just with no cost whatsoever. So let's briefly look at market structures, and I'm not just limiting the market structures to to the blockchain markets. Generally there is this this way how in financial markets actually markets are built. And let me start with the right side and in that left side. So the exchange market is the most common one. So when you go to New York Stock Exchange or Frankfurt Börse or something, you basically have one central system in the middle. Then you have different actors, mostly professional actors, actually transacting on that together. And that is pretty efficient, but it's also something that is actually giving a lot of limitations to the participants. It's also giving a lot of risks in how to interact with that, because it not only applies to every asset, but it's something where there's price discovery that is often a challenge. That's why you have professional market makers in that. So going further to the left, you then actually have these variations of that. So one of the variations is a sort of a broker-based OTC market. And I would argue, and it's probably a little hard to see on the right side, but that the dominant parts of the financial ecosystem today are being traded on OTC markets. Actually, if you look at the different asset classes, you know, equities actually being sort of in 2008 was at 16%. Now it's actually at, you know, roughly over 50% of the market is actually traded over OTC desks. So the majority of the market is actually not traded on public markets. And if you go across the different asset classes, bonds are by far like 75+% are actually traded on OTC markets. And you go down the list, so the average across equities, commodities, interest rates, crypto currencies is actually on average 52%. And we in the crypto market, we always look at centralized exchanges such as Binance, Kraken, etc., as the dominant places where actually things get traded. In fact, the current volume of OTC traded volume is 76%. So most of the value is actually not really traded with proper price discovery. It's actually traded bilaterally between parties, right? And we've seen actually in the past what the difficulty is with that. And there's two main things that actually come to mind. Actually, one is actually counterparty risk. So the way that an OTC trade happens is that the party that is the biggest balance sheet can dictate where it happens. So if I say, basically, I'm expecting to trade something, well, I'm going to have to subdue myself to the one that actually is the counterparty that actually has the say. Now, that's a trust thing, because the counterparty might just, if the market moves, not just nefariously, but if the market moves, they could just return and say, you know what, we've changed the deal, and actually you just have to accept the new terms, right? But the second piece is actually it might be underpriced. Because in fact, you're actually doing something in the assumption that it's fairly priced based on market, but actually it doesn't really have that transparency. You don't know actually what's happening behind the scenes. And so these two things are still today in the crypto markets one of the key things that actually keep a lot of people away, because it's actually limited to wholesale providers that deal with these big institutions, from DCG Group to Galaxy to other places. And I think the nature of the blockchain allows us obviously to go more to the P2P model, right? Really bilaterally to actually have a discovery that actually does it better. And let's go through actually what the benefits are there, because obviously it leads to that transparency. So we actually don't work on information asymmetry anymore. And a lot of these benefits actually are just general benefits about the blockchain, but as it applies to actually sort of these big trades and how they actually apply to these markets, it's quite significant. The counterparty risk, if it's a smart contract, I mean, this is what smart contracts are built for, to actually have a finality, a full settlement of what actually people want to trade on, and actually do that without anyone taking the middleman position in this case, right? So in this case, you can actually mitigate the entire risk of dealing with these two parties. And then even from a liquidity perspective, so we obviously sort of know from Uniswap and others that basically sort of a bonding curve-based trading model is already the precursor of that. But even if you go into low liquidity models where you have a data oracle that from the financial markets, in the case of real world assets, actually has a pretty proper price discovery, you don't, if you do it in the right way on the DOTC side or on an OTC side, you can actually have the same replication of liquidity on chain, and you don't have people subject to risk in that whole context, right? There's several other benefits, and we can go through them, but I think this is the core of what we think of hoping to solve for, because when thinking of these asset classes that are by far potentially 100 times larger than actually the crypto market, we have to be able to latch a hybrid of the off-chain markets with the on-chain markets. So let me introduce you to what we developed as a response, which is obviously built on long learning in the regulatory space. So normally, this function is being done by broker-dealers, it's done by centralized institutions, and they have a certain way how they have to be regulated. Now, if you do this in the decentralized blockchain-based markets, there is some benefit that you can actually do this in a fully non-governed and public service kind of way. So we actually introduced a couple of months ago, actually the first version of something called dotc.eth. And with the domain, you can already tell that it's basically, it's it's actually not served by a centralized server entirely. All the contracts are sort of non-governed. We don't have any say over them. They obviously will be not upgraded, but actually updated into a new experience over time. But anyone can go back to the original contract. So it's completely open. It has no limitations. But you can trade anything from ERC20s to 1155s. You can just quote your own price. You can actually then say whether it should be actually a full block trade or an incremental trade. And you can today already actually limit it to certain recipients. So if I actually say, you know, I fix a price with my counterparty, I can just say, okay, your wallet is the only one that can take this. It's fully collateralized in the smart contract, and there's no more this dispute of who goes first. So in this case, actually, the smart contract settles everything, and there's a full reconciliation happening between the two parties. Now, the exciting bit starts when the next level is actually sort of released, where we are introducing actually what we call auth select, which means that I can actually determine what the counterparty should be qualified by. So if I have a preference that someone is actually onboarding with me directly, and I need to know who that counterparty is from a financial market perspective, I could say that my offer is subject to someone being qualified. Or I can say, in this case, Swarm should be the qualification partner, or someone like, like BlockPass, or some other qualification vendor. Now, instead of making it static, the second thing we're going to be relaunching is dynamic pricing. So I can actually determine a data oracle that gives me sort of the reference price. So there's several data oracles out there today. You can actually quote NVIDIA, from a data oracle from Chainlink, and you can make that part of that offer. And then say, basically, I'm expecting not only that offer or that price, which might be floating, but I could say I want, a certain premium on top of it because it's a block trade, or I give a certain discount on it because it's a bigger trade. So it's up to me to define in what range, plus minimum and maximums, I want to trade this in. And if you think of that module, then it can actually be a pre-module that is available to other DEXs as a limit order book, right? Because in the end, I can say, well, you know what? Ethereum today is at 3,900. I'm willing to sell this amount, this block, at 4,500, and 4,500 to 4,700, and I'll just make that a standing offer. And I don't need to do anything. So I will be able to actually do that from within my safe. I will be able to stake the amounts that I'm willing to actually trade for that price. And then it's up to market makers from the outside or individuals to actually look into these kind of orders that are available and just take them when they're beneficial in the whole sense, right? So that will lead, obviously, to a completely new way how individual safeguarded environments transact with another, because they don't have to necessarily go to a public DEX. They don't actually necessarily have to go into the system, the broader ecosystem of a blockchain, but they have a direct interaction mechanism that allows them to discover better deals, but also be safeguarded around it. And what we'll actually include in that as well is something called affiliate participation. So, in some ways, bringing attention to these individual deals is a channel function. And so you think of Safe, for example, today, they basically should deserve, for bringing the consumer to a protocol like us, they should deserve to actually participate in that deal too. And that's going to be embedded into the protocol itself, that for those instances, they will be able to get a piece of the fee that is being taken out of the transaction to then actually sort of have an incentive also to actually go out and do more of that. So we think, overall speaking, that this is a crucial component that is an additional layer that is needed today, because we believe big time in DeFi, and everyone's right to say that basically DeFi was the successful infrastructure that continued working while actually the last the system was actually melting down with Luna and Celsius, etc. But in this case, actually, it's something that actually lets me as a consumer, as an investor, actually take a little bit of a hands-off approach, and actually has the same kind of convenience as if it was a centralized system. And it allows them to actually do things in almost, it feels like it's a centralized way without the centralized counterparty risk. That's it. Thank you so much.
Thank you, Philip. We have some time for some questions, if you guys have any. Okay, then I will see you in 5-10 minutes.
There's one.
Up
There's
next.
no. This is it.
Yeah. Okay. Thank you very much.
All right.
Thank
Thank
you,
you so
Philip,
much.
for your time. Hello, hello. So welcome to our last talk of the day. We have up next Angela Kreitenweiss from Token Engineering, talking about managing complexity in token systems with large language models. Thank you, Angela.
Hello. Yeah, hi everyone. I'm Angela Kreitenweiss. I founded the Token Engineering Academy, and today I'll talk about managing complexity in token systems with large language models. Maybe for those who haven't heard about token engineering, some words about this new crypto-native discipline. It's the design, verification, and optimization of token-based economic systems, and as such, it is a new discipline in its own right, combining computer science, cryptography, game theory, economics. We draw from industrial and systems engineering, control theory, AI operations research, and we have the human layer with psychology, decision science, political science, governance, if you think of DAOs, and philosophy, law, and ethics. And this combination of disciplines is new, and TE Academy is the first organization to offer education in this sector. Complex systems, token systems are complex systems. They show many properties of complex systems. Like in software complexity, of course, this is a diagram showing Aves contract interaction. So we have dependencies on the software level, and we have dependencies on the economic level. This is a typical diagram token engineers draw when mapping out a system design. So you see the arrows, the value flows, the cylinders, the pools, initial supply, reserves, you see the romp symbols. These show the policies and the mechanisms involved, and we also see some clouds, which are external systems we can't control and we don't model at this point. We have several layers that we want and have to observe and keep in mind in the design of token systems. We have dynamics over time, so these systems emerge and evolve over time. And we have interactions between mechanisms. And on top of that, we have activities of actors whose behavior we can't predict. And that's why token engineers run system verification and optimization, because we can't go with spreadsheet calculations. We have to simulate our system to observe the properties and to see if we get if we have flaws in the design, or if we get to edge cases or dangerous system states. And to observe these systems and to test them, to stress test them, we build models of our systems. And you can imagine no software, no simulation model can replicate the real world. So we have to take decisions on how to build a model to represent the world that we want to test and that we want to verify, and we have to understand and gain a good understanding if this model is capable to produce reliable and valuable insights. So this is decision making when it comes to how should our model look like and how can we simulate the token system. Here's another example of a tool. This is Zenit Finance. It allows project teams to simulate the token distribution. And if you look at the left, you see some inputs like a token price or a total supply to then gain an understanding of supply and demand, of buying and selling dynamics. And if the token price and the supply are inputs, then we determine in such a simulation with what values, with what parameter settings we'd like to run. Meaning we don't predict price here. We go with assumptions about price and the right setting of supply to understand the dynamics of supply and demand under certain circumstances. So my message is, as a token engineer and generally, if we want to understand and design token systems well, we have to take decisions and we have to go with assumptions. And as in any other example of complex systems, we have to be very aware of our assumptions to then draw the right conclusions in order to then make the most of amazing tools we have at hand, AI and machine learning, to cluster and classify, detect patterns in transactions and behavior, to go with symbolic regressions to find mathematical relationships in data, to go with stress testing based on synthetic data, LLMs or VAE, or to use agent-based models and adaptive agents even to simulate our economy. So we have this interplay between human and machine reasoning. We, human designers, project teams, communities, take decisions on the purpose, on the goals of a certain design, and on the purpose of a token network. Then we use machine intelligence to understand, to run vast amounts of simulation runs, process vast amount of data, and apply smart methods to understand what could go wrong, if we are on the right track, how to secure an economy. And we draw conclusions from these insights in modeling and simulations, adapt the design, and then again, machines help us to understand the consequences of these design changes. It's like a conversation, which brings us to LLMs. Some months ago, we started asking, can we use LLMs to interact with models and simulations in a way that we can prompt LLMs to run simulations, and we not only expect an answer on a certain question, we can interact in order to change parameters and to let AI agents run analysis or even visualizations of the results. This is a project where I was collaborating with my colleague Rohan Mehta, and we called it CatCat-GPT. So the general idea is that we have a system model, what I was mentioning earlier, a moment ago. We build a model of our token system, and we have optimization techniques at hand. Machine learning, reinforcement learning. And on top of that, we use a layer of AI agents so that we can interact with the system model, run optimization techniques using human language. CatCat-GPT is the result, and it's a framework. It's available open source, and it's basically you can use it on top of any CatCat-RedCat model. CatCat and RedCat probably are the most powerful Python libraries for running token system simulations today. And we use the objects of CatCat models to access the model and then have three main components: memory, the core CatCat-GPT chatbot, and toolkits. Memory on top is information that LLMs off the shelf don't have access to. Information about our token system, information about a protocol. It can be documentation about the model at hand and data in tabled forms and also in vector databases. And the toolkit at the bottom are Python functions. We can access and execute Python functions through our chatbot. And this is the core piece of innovation in CatCat-GPT. So we have a chatbot that for the user has a user input in natural language and a user output in natural language. And at its core, there's a planner agent and an executor agent. And to be of any value for token engineers, these AI agents have to A, make sense of the human input, B, reason about the steps needed to get to a certain output, also reason about the memory and toolkits needed, plus decide on the sequence of steps. And here's where this deviates hugely and provides additional benefits compared to software as we know it today, because we don't predefine and determine the workflows. It's on the agents to decide how to combine memory and toolkits and how to run the steps to get to a certain result. And they run and execute based on contextual decisions in every single step. And it's amazing to see the capabilities of AI agent when it comes to taking a simple user input in a natural language and then go through all the steps needed to run a simulation and produce an output. Some more words. So at the top, we have long-term memory and short-term memory. Short-term memory is the history, the message history, what we have at hand based on an individual conversation. With the chat, we have new opportunities coming up with GPT-4o. And we have long-term memory, which is, for example, documentation of the model or other, think of the docs for any protocol to inform about a certain token system. We can store it or create embeddings and make it accessible and searchable for the AI agents in vector databases. And at the lower end, some examples for toolkits. We can run typical Python functions, statistical methods. We can access APIs to get data, on-chain data, off-chain data, and we can create dedicated agents as part of the toolkit. And the planner agent takes in the user input, reasons about the steps needed, about the tools and the context, creates a task list, and then hands over to the executor agent who is delivering results of sub-steps, step by step, again, applies reasoning about the steps needed, and then produces the output, including a documentation of the steps. And this is inspired by Baby AGI, AI-powered task completion, or React. Now, again, looking at this combination, we have the system model in the back, we have optimization techniques, and we have the layer of LLMs to make this accessible via natural language. It would not only be suitable for token engineers, basically it makes reasoning and decisions about a system design accessible to many more stakeholders. So we have, again, a perfect loop in human and machine reasoning, which could be applied to many more cases, not only cat-cat simulations. And this brought us to RetroPGF. RetroPGF is a funding paradigm and concept invented in the optimism community to fund public goods that are valuable to further develop the optimism ecosystem. And these public goods have been funded in 3 rounds so far. And if you look on the right, round 3 distributed 30 million optimism tokens to the ecosystem, to projects providing value to the optimism network. And by the time of decision making in round 3, this was worth 120 million USD. So this is a significant amount. And at the same time on the right, we have the number of projects also growing rapidly to 500 or 501 projects in RetroPGF round 3. And the decision making on what projects are actually valuable, and since RetroPGF is retroactive funding, evaluating the value they created for the optimism network, of course, this is a challenge. So we started exploring in February how AI co-pilots could help the decision makers in Optimism RetroPGF to evaluate projects, to interact with data, the system model with applications in human language, to run data analysis and even have access to much more complex simulations without writing code. And this is actually highly needed in DAO ecosystems, since on one hand, we want to have this diversity of projects, so it's hard to put them in boxes and evaluate with only 1 or 5 metrics. And on the other hand, equivalently, we want to have decision makers with a multitude of backgrounds. So how can we facilitate the evaluation in this case, and how can we build tools to have better insights and better data-driven objective decision making? And this brought us to building RetroPGF GPT. So again, what would be the equivalent of memory for RetroPGF GPT? Of course, data that is relevant in the context of optimism and RetroPGF. And this can be, for example, application data, data that projects submit. And again, more than 500 projects, their data, their achievements. This is something that is hard to evaluate manually, right? Then here we have an example of the funding results in a public GitHub. So this is accessible publicly. Or the impact equals profit. This is the key paradigm of how should we distribute funding to grow public goods in the optimism network. We define it as the grants received from projects should be equal to the positive impact they created for optimism, round by round by round. This sounds simple. It's actually hard to translate. Now, let's take a look at potential queries. So with LLMs, we can query applications. Like on the left, this is the user question, and on the right, you see the agent's output. So please list impact categories with the number of applicants and percentage of applicants funded. So match holders and decision makers have access to prior rounds, to the number and the sizes of these rounds. We can query funding results. So, for example, provide the funding range per impact category. So we see the total applications, the average median received in funding, the percentage funded, etc. We can, as a decision maker, I can compare my voting to overall results to see my alignment with the overall community, project by project. Here we have a list of projects, how much optimism tokens they received, and my vote, and also the deviation. So there are many lenses we can explore the data available and the funding rounds in RetroPGF. Some more words on the toolkit. The equivalent of the toolkits in CACA-GPT apply to RetroPGF. Some months ago, a discussion started, a very valid discussion started on how can we improve the evaluation of projects. And there has been some experiments, now also in round 4, that is starting in early June, to apply metrics-based evaluation. So in the past, it was up to the decision makers to define their own criteria, how to evaluate projects, and to come up with their own decision, how to allocate funding. And this is great when it comes to diversity and diverse perspectives. On the other hand, then it's hard to see if the community is aligned in the goals and in the ultimate purpose of RetroPGF. Okay, metrics-based evaluation could be one solution. Let's set up some metrics that seem to be useful for measuring the impact. Impact equals profit. And this is a screenshot of an early tool. And you can see on the right that there are some metrics like total transactions, projects, how frequently the smart contracts of a project have been utilized, or total transaction fees. So how many fees were created based on the project's contracts. And these numbers, of course, matter when it comes to how the value or the impact they created for the optimism network. Now, going further, we can look at, okay, if we have this toolkit and the community decided on metrics to apply how to evaluate projects, I can take a look and play with these metrics to see, for example, show me the alignment score. This is now a metric to show the difference between my vote versus the overall outcome. And I can even better understand metrics, asking in, can you explain me the alignment score? And this is often the challenge when people are looking at dashboards. How is this metric actually calculated? What does it say? What metrics or what values, what data does it use to, what data is processed, what's taken in, what's the inputs, and what's the output, to understand how this metric matters for my own decision. And LLMs can help us in understanding these metrics. Now, you might ask, okay, a voting single round is basically a calculation, and this is something that is not so super complex. However, if we look at this voting design, the logic, how RetroPGF distributes funds, this is actually relevant for the total optimism economy. Let's take a closer look. If we have RetroPGF, we distribute funds to valuable projects, and that way we grow developer activities and projects. Now remember, 30 millions distributed in round 3. This has an impact on secondary markets, right? Because it increases the optimism supply significantly. And not all projects might be able to just hold. Some might be forced to sell their optimism tokens to cover their costs. And so it has an effect on the price, and it has an effect on the fee revenues of the protocol, because it affects the price of transactions. Now, this could be a positive effect, because in USD value, this decreases the costs of every single transaction. This would be good. It definitely has an effect long-term on RetroPGF, because the fee revenues fuel the funds available for RetroPGF. And there's another effect of the developer activities and the projects on fee revenues. Because remember, the metrics shown beforehand, depending on the projects and what they build, they can, of course, affect the fee revenues via increasing block space demand, via the applications built on top of the protocol. And there's a final impact, if we look at secondary markets, to RetroPGF, because, of course, the dollar value of optimism tokens drives the funds available. If you look at the volatility of the token in the networks, of course it has an effect if the value decreases by 50% in how attractive is the funding RetroPGF for projects. So if we take a look at the system perspective, we see that only this this individual RetroPGF is not an isolated thing. It has an impact on the total optimism system. And via simulations, we can ask, how does RetroPGF impact the network growth of optimism or any other token system? How does RetroPGF impact the network value? And what are the best metrics to evaluate these evaluation criteria that should be also hard to game? And how can we align incentives so that not only the projects, also the decision makers have skin in the game, as well as the optimism token holders overall? RetroPGF GPT is one way to make the systemic perspective more accessible to any stakeholder, to any decision makers in DAOs. It can help us to understand individual rounds, voting designs, the system perspective, how this affects the total optimism economy, and it helps us in taking objective and data-driven decisions. These are some of the requirements we've set up for RetroPGF GPT, like we want to make this equipped with an ever-growing set of tools and information. This makes total sense. If you think of the memory and the information that is ever-growing and is in evolution every single day about the optimism network and collective, the tools to measure impact, the tools to measure the effects of changes in RetroPGF on the total ecosystem. This has to be modular. Of course, it's also relevant how much we open source to grow the knowledge of the overall ecosystem. No open AI lock-in whenever possible. Let's see how alternative LLMs can cater the needs. A modular framework on the tool side, on the metric side with the DAO to take decisions on what are the most valuable metrics to observe, value add. And it also can inform how we collect data about projects, how this data is structured to make the most of the LLMs and have optimal quality in the results. And last but not least, this is also new areas for all decision makers because it's different to interact with LLMs in human language. It has many benefits, but we also have to understand the flaws. Overall, can LLMs support decision-making in DAO systems? Yes. Are they capable to become the interface between data, metrics, simulations, and human decision makers? Think of this loop. Absolutely, yes. Can we improve data-driven objective decision-making and optimization? Yes. And work is needed for sure when it comes to the memories, the information available, the function calling, the metrics, and the improvements and further development of this planning execution. This is the most important aspect. We want to have auditable and reproducible results and reliable results based on LLM interactions. That's it. And finally, we are running a study season at the Token Engineering Academy. You can find it at tokenengineering.net. If you're interested in complex systems and token systems, check it out. Thanks for today.
Thank you, Angela. If you guys have any questions, go for it. If not, we're wrapping up here. Thank you so much for your time. And thank you guys for assisting.